Welcome to Hot Chips 30. Tutorial 1. Blockchains and Distributed Ledgers.
So good morning. Welcome to Hot Chips, to the first tutorial. My name is Geoffrey Burr from IBM Research Almaden, and I'll serve as the session chair for this first tutorial until about lunch. I do have one message from the organizers that I've been asked to deliver before I introduce our first speaker, which is to remind you to put the parking pass, and not just any parking pass, but the right parking pass for today on your dashboard of your car. And make sure it's there. And with that, I would like to introduce the first speaker of our tutorial. He'll speak to about 11:15. And so it's an honor to have here Dr. C. Mohan from IBM. Dr. Mohan has been an IBM researcher for 35 years in the database area, impacting numerous IBM and non-IBM products, the research academic communities, and standards, especially with his invention of the Aries family of database locking and recovery algorithms, and the presumed abort commit protocol. An IBM fellow since 1997, and ACM IEEE fellow since 2002, he also served as the IBM India chief scientist for 3 years. In addition to receiving the ACM Sigmod Innovations Award, the VLDB 10-year Best Paper Award, and numerous IBM awards, Mohan was elected to the US and Indian National Academies of Engineering in 2009 and was named an IBM Master Inventor in 1997. A distinguished alumnus of IIT Madras, Mohan received his PhD from the University of Texas at Austin. I will skip the year. And he is an inventor of 50 patents and is currently focused on blockchain, big data, and HTAP technologies. With that, I ask you to welcome Dr. Mohan.
Thank you, Jeff. Good morning, everybody. Thanks for coming on a Sunday morning to listen to this material. It's nice to be in this auditorium. I've been only on the other side in the past. This is the first time I'm on the stage in this very famous Flint Center. So this presentation I've been giving since April of last year. That was my first presentation on blockchain, and that was in actually 2 universities in Hong Kong. Since then, I've given it in 9 countries, and I'm about to go to Brazil on Friday, and so the International Conference on Very Large Databases is taking place there in Rio, and so that'll be the 10th country. So it's been incredible in terms of the amount of interest that has been shown across the globe, and that's the point in saying, 10 countries and so on, in this topic, much more so than what I worked on for 35 plus years, which is hardcore database topics. Since my research lab in San Jose is where relational databases came into existence, Ted Card, the guy who got the Turing Award for that work, used to be my colleague. And also the language SQL came from my research lab. So all the other things that happened were as a consequence of this kind of activity that happened in my research lab. So I've been a hardcore database guy working on recovery, locking, and such topics, really low-level nitty-gritty, details-oriented stuff. So all my professional life, I've been at IBM, but I also have this affiliation with Tsinghua University as a distinguished visiting professor for the last couple of years. Plus, I was the IBM India chief scientist based in Bangalore for almost 3 years, from middle of 2006. So what you will find is that in this presentation, all this long history I've had working on industrial strength database technologies is something that will be of great relevance because there's been too much hoopla in this space that's based more on people not really systems-oriented people doing things and making all sorts of tall claims about how open blockchains are going to solve the world hunger problem and all sorts of, incredible claims that have been made with decentralization and no trust, blah, blah, blah. All sorts of goodies can come. But in fact, they wasted a lot of energy and such with these open blockchains, with this notion of proof of work and such. Of course, as most of you probably are chips and such people, maybe, at least some of you don't care for all the energy wastage that's happening in this particular space with special purpose chips even being developed, ASICs and so on, in order to do this proof of work computation more efficiently and things like that. But I have fundamental problems with that whole approach, in fact. That's the right thing to be doing. So my major focus will be on what I call private blockchains, which have the potential to really be of practical consequence rather than fringe people or people who are out to try to make money really fast through ICOs and all these terms that you will be hearing, which are different from IPOs, initial coin offerings, instead of initial public offerings. I'm not so fond of that kind of activity. I'm more into making a real-world difference with things that have the potential to become practically very relevant and so on. So in case you are interested in looking at the slides, I've already tweeted, so my handle you see there, SEEMOHAN, as well as in other social media forums. I put the link, just did it this morning. So it should be easy for you to go look at the bit.ly link. The other point I want to make is that the bit.ly link that you see at the bottom of the slide, if you go there, you'll find lots of very useful information, links to PowerPoints and presentations and papers, both very technical papers as well as more fluffy white paper kind of documents, and also good Twitter handles to follow and things like that. So if you like the presentation and you want to learn more, or you want to tell your friends who are not here about this work, please point them to that, share and tweet and all that, because I'm really out to evangelize these private blockchains, which, as I said, are the ones I believe are going to really make a difference as opposed to overnight millionaires and such things that are the norm with a lot of cheating and all that that's going on in the public blockchain space. There are good things also happening, but more of it is hype than good, really. So, okay, let's see. So this slide, unfortunately, okay, sorry, I skipped this slide. So this gives you the overview of the presentation. Basically, it's targeted at anyone that might or might not have had any exposure at all to blockchains. And it's even targeted at non-technical people, which doesn't apply to, I'm sure, any of you, because I'm sure you're all technical people. So I'll introduce the topic and give you some pointers to other places where you can find even more detailed information and so on. So I'll be going into different levels of abstraction. Sometimes I'll be at the 10,000-foot level. Sometimes I'll get into the weeds and so on. So, of course, as you probably know, I'm here for the first time. So Jeff is going to be the man who is going to police the questioning and all that. And if you want, you could ask questions in the middle. The only problem is, given the size of the auditorium and the fact that some of you chose to stay way behind rather than being up front when there are so many seats here. There are two microphones, one you see there and another one over there. You have to come there to ask the question. I assume it's being recorded also, so for that reason too, they want to make sure that you don't just shout it out in case that doesn't get picked up by the microphone for the recording purposes. So, but definitely there'll be time at the end, and I'll also hang around during the break as well as the lunch. So I'm going to be listening to the next presentation also on Ripple. So I'm going to also skip, as a result, some of the material that I normally show about Ripple, which the next speaker from the Ripple organization itself will be talking about. So I'll talk about some of the applications, use case scenarios that go far beyond just the fintech space, which is where some people keep thinking that because of the concept of cryptocurrency and all that, that's where the major focus is. In fact, there are many non-financial industry use cases that have become really heavily focused on, and there are even production deployments and things like that. I'll also say a few words about the market scene and some standards activities that are in progress. It has to be understood that in this space right now there are no standards. It's somewhat chaotic, but not as chaotic as, let's say, the NoSQL space, for those of you who are more software-oriented. There isn't like a SQL language standard in this space. And so, as a result, you need to be very careful if you're choosing a system, which system you use, because its APIs are going to be different from some other systems' APIs that are out there. More importantly, there isn't even a conceptual model for these blockchains that's common across these different systems whose APIs might be different. If you think of the relational arena, when the original implementation was going on in my lab, SQL language came about as a result, whereas at Berkeley, Mike Stonebreaker and others were with the same relational model developing a system, but they developed their own language called Quell. But at least the underlying conceptual model was the same, whereas here even that is not the case, as you will see. In terms of architectural choices, I'll discuss some of the choices that have been made. When I say architecture here, not necessarily computer architecture, but even the software architecture, elements of that architecture, different choices have been made by the different systems. I'll also give you some of the details of some systems that are out there, and then areas that require a lot more work and so on. So you have to think of this whole space, at least the private blockchain space, to be in the same state as relational database systems were 40 years ago. A lot of stuff had to happen before they became really, useful and easy to use, and all sorts of tooling and all that got developed. So in terms of, for those people who might be looking to start companies or start research projects, whether you're a student or a faculty member, in any kind of research organization, either commercial labs like mine or in academia, there's a lot of scope, and we'll discuss some of that at the very end. So this slide, I'm sorry you can't easily see it unless you maybe go, if you have your laptop, and look at the presentation itself, is trying to summarize exactly how all this came about and so on. So the initial work that triggered all this current mania, if you like, in the blockchain space came from this paper that was written with a pen name, but a Japanese-sounding name. Nobody knows who the real person is or real persons are that were behind the paper on Bitcoin. So the idea behind that paper was that, fiat currencies are bad, so we are going to cook up this new kind of currency, which is like magic, you just waste a lot of energy and suddenly you create some coins called Bitcoin. And I'll get into some of the details a bit later. But the underlying data structure for this Bitcoin is the blockchain. So we are more interested in that underlying data structure than the notion of Bitcoin itself. And all the subsequent developments that have taken place have resulted in many more such cryptocurrencies coming into existence. Ether and all sorts of ICOs that I mentioned. Many companies are cooking up their own things, tokens or coins, they call them, virtual coins. There are various terms that are floating around for these things. But in general, there is a certain passionate set of people out there who think governments are bad, and since fiat currencies are issued by governments, these libertarian kind of oriented people think by just coming up with a single virtual currency, cryptocurrency, somehow all the world's ills will be taken care of. This is all wishful thinking. So those of you who have been old enough to have been around when people thought linguistic problems of the world could be solved by coming up with a single language, that didn't happen. There is no chance in hell that any of this is going to be true, that one currency, whether it's crypto or non-crypto, is going to be adopted by the whole world. So having seen the hype that was made at one point with a natural language being adopted widely and that not coming to fruition, and already there is sign now that there are so many of these cryptocurrencies themselves. It's not like Bitcoin is the only thing around the globe that's there, but it's become also a big problem in terms of performance and so on. So if you look at the numbers there, 7 transactions per second and 10 minutes for the outcome of a transaction to be known, whether it succeeded or not, where a transaction is essentially sending a certain number of Bitcoins from one person to another person. I mean, there were like 35 years ago, we used to talk about 1,000 transactions per second in the traditional database transaction processing arena as some big deal thing. And of course, now, now we talk about millions of transactions per second and things like that, especially in the IoT context and streaming and such. So for such people, this is like, are you kidding that this is anything that is going to be of any practical relevance and so on? But there are people who are, especially a lot of 20-somethings, who think somehow this technology is going to really get rid of all sorts of ills of society. And so, of course, as it happens with this kind of thing, as these new currencies came, now you have to worry about the conversion factors between them. People who complained about the fact that, oh, China is manipulating its currency or this or that, artificially keeping its value low and such, thought somehow this Bitcoin will solve all that problem. But now that you have many more such currencies, you are back to the problem of who gets to decide and all the manipulation that goes on with respect to the conversions between these different currencies themselves, or between these different currencies and fiat currencies. So, but in any case, the world is now very excited about this, both the technical world as well as the common man kind of world. So popular press has published a lot of articles, and there are various groups across the globe that are working on various aspects of blockchain technology, from, let's say, the topic of security to consensus to database and benchmarking and on, verification and so on. The notion of smart contract got introduced as an extension of what was there in the original Bitcoin paper, where the only resource that was being managed using this blockchain data structure was this entity called Bitcoin, or your wallet, which contains Bitcoins, right? And then being able to transact by sending these Bitcoins around, to then saying, hey, we would like to use this blockchain technology to manage any kind of resource, be it a purely digital resource like music recording or a video recording, or digital representations of physical assets like diamonds and packages and spare parts and componentry, all sorts of things that you and I as ordinary citizens will be dealing with in our day-to-day lives. And so it's that transformation that's the more exciting thing. And so now we'll get into, in due course of time, the details of exactly what the big deal is with using this blockchain technology versus using traditional databases and so on to do the same sort of thing. But you have to keep in mind that all of this is very relevant only when you are dealing with a business process or a workflow that involves many organizations. If it's just something that's internal to an organization, the chances are pretty slim that you would need to use something like blockchain. But in terms of the actual real-world adoption of this technology, while there are lots of prototyping activities and POCs being done, there are actually, since early last year, production deployments all over the place. In particular, the first one had to do with an offshore fund management entity in the Guernsey Island of the British coast, where private equity funds are being managed using a particular piece of software which was developed initially by IBM, and then it open sourced it and became part of a consortium, and that's the Hyperledger Fabric 0.6 release. Okay? 0.5 was the first release, 0.6, and then the even more production strength thing that was released middle of last year, about a year ago, is the 1.0 release. And but these guys went production with even the earlier than 1.0 release of that system, which is now developed in a consortium fashion under the Linux Foundation, since this Hyperledger Consortium is part of the Linux Foundation. But there are many other projects under that foundation's umbrella, and we'll talk about some of them, including, for example, Sawtooth, which Intel initiated, and that's had its 1.0 release come out more recently. This 1.0 release is considered a big deal. That's a statement by the consortium which says that this is ready for prime time kind of statement. So meanwhile, IBM announced blockchain as a service offering. You'll see lots of other vendors also making announcements, if not actually making their BaaS offerings available. In particular, for example, Oracle has announced last October that similar to the IBM offering, based on the blockchain Hyperledger Fabric 1.0 release, they will have a blockchain cloud service. But it's not yet available. It's supposed to become available in the next few weeks and so on. That's what they've been saying for the last few months. But IBM's offering has been out there even based on the 0.6 release, and it runs on the mainframe, believe it or not, leveraging some really fancy features of the mainframe, which are even far superior compared to the SGX feature in Intel platform, which has to do with secure execution enclave. And we'll talk about that also a bit later. But more recently, that IBM offering is now called the IBM Blockchain Platform since the 1.0 release of the Fabric. And that has been deployed also in production mode by various people that have implemented solutions on it. The distinction is that you can download the open source software and run your own thing. But if you want a managed offering, that's what this blockchain as a service is, which means you have to pay some money to IBM. And there are others, Huawei and so on, that have also come up with such things. And there's more of it that's going on. And also the Hyperledger Consortium started a project fairly recently, which is attempting to come up with benchmarks. It's called the Calipo project. And the original Bitcoin work got extended with the notion of smart contract that I was mentioning to manage different kinds of assets than just a cryptocurrency. And that resulted in a system called Ethereum being developed. But that also had the same sort of problems as the Bitcoin system, namely the way in which things worked over there. For instance, how a set of new transactions get to be put up for being executed, and who succeeds in getting a new block of transactions getting executed is determined by this concept of proof of work, which is essentially a way of making the different people who are attempting to get the opportunity to add a new block of transaction to the existing blockchain to solve a math problem. This was an attempt to, by the original designer, in the presence of any kind of people out there whose identity you don't even know, to make them go through some pain in order to make sure that they are not out to screw up the system. See, this is the so-called Byzantine behavior that they are worried about, which is not just the traditional kinds of failures where a node fails or a disk drive fails or a communication link fails, but you also have people who are intentionally trying to screw up things where they might say one thing to one person or one system and just the opposite thing to another person or system, when in fact they are supposedly saying something about a particular fact or whatever, and they are giving conflicting information. It might be reminiscent of something else that's going on in this day and age in our country, but let's not get to those sorts of discussions. But all this, lying and everything. So in order to prevent people from hijacking the whole blockchain way of doing business by people who exhibit Byzantine behavior, they came up with this idea of making them waste in my words, a lot of energy so that, it'll appear like they are being serious, and hence there's less likelihood of them being these bad actors, okay? But that's what results in this incredibly lousy performance of 7 transactions per second and things like that. So this notion of asking people to solve a problem, which is this proof of work idea, is part of the Ethereum way of doing business also, which as a result also makes the performance there not at all that good. Of course, there are attempts to address these sorts of issues by coming up with a different, these things are called consensus protocols, proof of work, proof of stake, and various other ones that are being proposed as we speak. There's even a Turing Award winner at MIT who has come up with his own, Silvio Micali, and I'll be discussing these things with him next month at the Heidelberg Laureate Forum in Germany. Along those lines, the Ethereum system also is an open blockchain because anyone, anywhere can willy-nilly come and go without having to reveal his or her identity. And that also is a bigger problem because everybody can see what's being transacted on such an open blockchain. It's open kimono kind of way of doing business, which real enterprises and other kinds of organizations that worry about privacy and such, or competitiveness between organizations, are not going to be happy with. And that's another reason not to let anyone anywhere come into the party without any checking being done as to who they are and so on. So that's the way the private blockchain deals with this issue, so that only people who have a reason to be there, because they are participants in a business process, will be allowed to be members of a private blockchain network. And the current participants get to decide who the new participants can be. And it's not just because somebody has some, compute resources available and they have nothing else to do that they just come and join the party, which is the way things work. And as you probably all have heard of these server farms up the wazoo that are in China and certain parts of Canada and other parts of the world, whose sole job is to, with special purpose chips and so on, try to do this mining, because the people who do the mining, proof of work, and who win the competition, because multiple people are trying to do the same thing, get a few biscuits thrown at them. It's like a dog does a trick and then you throw a few biscuits to reward it kind of thing. So in this scenario, the bitcoins get thrown at them. So, and that's how bitcoins get created, as opposed to being just moved around, because you have to worry about where do they originate. And the paper also artificially set a limit on ultimately how many bitcoins will exist in the world. Again, who are these people who are coming up with such things? They are not economists. And so, yeah, you can say, in fiat currency, governments are willy-nilly printing notes and so on, but there are enough checks and balances in the governmental way of doing things that fiat currencies, even though you can give examples of Argentina and some countries where things have gone crazy and such, still across the globe, the Federal Reserve, the Central Bank, the Reserve Bank of India, and such organizations out there that do police this kind of activity, and they try to relate it to real-world services and goods that get produced, not this, I'm just a computer geek and I'm going to cook up some algorithm and think that I'm creating money with no real relationship to real-world economic indicators of productivity and so on. So this is the other reason why this is a problem. In any case, even the Ethereum people, in due course of time, have realized that at least in certain scenarios, they need to have this private blockchain orientation, and hence the emergence of what's called the Enterprise Ethereum Alliance, which is trying to take the Ethereum technology and bring it into the private blockchain domain. And in terms of the market, it turns out this global blockchain technology market by Grandview Research has estimated it to be about $7.74 billion by 2024. These sorts of numbers, you just want to get an idea of the order of magnitude, not the exact numbers and so on. Somehow these guys cook up these things, Gartner, IDC, and so on, as to what the future market will be and things like that. So my focus will be on the private permission blockchain. In terms of job markets, and some of you might be interested, there are lots of jobs out there for people who are willing to work on either the private blockchain or the public blockchain. So these are some of the headlines from some articles. Cryptocurrencies and blockchain are becoming a hot trend in the job market. Blockchain moves into top spot for hottest job skills, blockchain jobs and salaries, 2018 report, and so on. So if you go to the presentation, you'll see more of this kind of information. In terms of also jobs and particular geographies, as you can see here, the New York and San Francisco cities have lots of job opportunities. Silicon Valley doesn't show up as a separate category, but individual cities are there. That's why you'll see Palo Alto and Menlo Park and Sunnyvale and so on also there. This is just to get you an idea of what the different kinds of areas are in which there are job openings. So the key there says unemployment rate, number of crypto funds, number of blockchain startups, number of top blockchain companies, number of blockchain job postings, okay? If you are from Europe, how many of you are non-US based people? Okay, pretty small number, okay. If you are from Europe, there are a whole bunch of projects that have been initiated by the European Union, and this slide, when you go click on it, it'll point you to various projects and so on. So in terms of organizations, it's small companies, big companies, it's NGOs, it's venture firms, governmental entities, all sorts of parties, little countries and big countries that are all working on these things. I've already discussed what the Bitcoin's original goal was, to create this notion of Bitcoin, a cryptocurrency, and then let people, for presumably goods and services that are being exchanged, real-world goods and services, pay each other using Bitcoin. So the way it works in terms of identity, you don't really reveal your identity. There is an address that's unique that essentially represents you, a particular person, and there's a leveraging of public key and private key. So you expose to other people your public key, but you hide from everybody else your private key, and other people will send you money using your public key and your address. If you lose your wallet, which is where you are keeping your money that is in your account, you are completely gone. Meaning, if you forget your private key, there's no recourse to any authority or anybody. So in that sense also, this is all very crazy, It's not like having money in a bank, FDIC insured, this, that, and such. Of course, as you can imagine, because it has this anonymity, there are any number of people who are out there to do all sorts of sleazy things who have leveraged it, from drugs to prostitution to black money and so on. So countries like India and various other countries, including the US, there are many people whose eyes light up because now they think they can very easily convert their fiat currency into Bitcoin, and then they can move it around the globe and do all sorts of dealings that are under the radar of governmental authorities. For that reason also, many governments are not happy with it, and actually many governments have banned these cryptocurrencies in general, not just Bitcoin. And so currently there's a lot of debate also about, are these things like securities or not, and so on. This whole ICO notion was introduced by some people who wanted to raise money in the market without going through all the regulatory requirements of IPOs. Should be reminiscent of what happened in 2007 and 2008 with these mortgage-backed securities and such concoctions, which were primarily targeted at circumventing the SEC kind of regulations and federal policing and such. And we know what the disastrous consequences were of that thing. So in that sense also, currently there's a lot of concern about what's going to happen with these things. In any case, this just shows a particular scenario where Bob and Alice are exchanging some money, okay? In terms of how this thing works, if you're a geeky kind who wants to get into the weeds, there's this concept of, as I said, money being created that's done through what's called coin-based transactions. The money gets created because they want to reward somebody who took the trouble to solve that math problem, do the proof of work, and got the opportunity as a result to add a new block of transactions to the existing blockchain. So the blockchain starts with nothing in it, and from then on, money gets created and also gets exchanged. And so I don't know how it gets initialized, because what is there to transact to begin with? Nobody has any money. So I'm not sure what the initial transactions are doing in this kind of a scenario, but let's ignore that for the time being. But in general, the transactions are A sends money to B. Now, that transaction is declared to have actually happened successfully only after these miners verify that, in fact, A had enough money to actually send this, whatever, 5 bitcoins to B. And that the same 5 bitcoins are not being sent to multiple people. That's called the double spend problem. This is like running to an ATM and grabbing money and then going to another ATM before the central server gets updated with the reduction from the first withdrawal. You go take money from another ATM. This sort of silly things used to happen in the good old days. But anyway, here, so the idea is that you start a transaction, but it'll be a while, like 10 minutes, before you find out whether that particular transaction succeeded or not. And that's also kind of mind-bogglingly dumb. The way the whole thing works, they don't even keep the current balance in order to check this, is this a legit transaction? They actually go back to the beginning of that blockchain, look through all the transactions that this person has been involved, the one that's sending the money, and then they compute. For every transaction that this guy does, they compute what his current balance is. Given that current balance, is this transaction that this guy attempting to do acceptable, or is it legal or not? Legal in the sense of it's legit in this context, that he does have the money that he's trying to send. So from a computer science viewpoint also, this is all pretty inefficient way of doing business. And if the blockchain has existed for 10 years, imagine rummaging through all those 10 years worth of transactions and figuring out whether the current transaction makes sense or not. If you want to know more about some of the data structural aspects of what this blockchain thing looks like, for those of you who are into logging and recovery in systems, this is nothing but a log of the different transactions that have taken place over time. But unlike a traditional recovery log where we don't worry about Byzantine behavior and such, here the data structure has enough features built into it to make sure that if somebody tampers with a page of this blockchain or multiple pages of the blockchain, the fact that it's a tampered version than the original version can be detected. You'll hear a lot of these phrases like immutability of the blockchain. It's not all that novel. I mean, traditional database recovery logs, we never do in-place update. We only append new transactions to the log. This is no different from, in a banking context, ledgers, let's say you deposited a $1,000 check, but erroneously it got recorded as a $100 check. And then you later find out when you get your monthly statement out, oh, what the heck? I mean, this is wrong, clearly. So you go argue with the bank people. When they fix that error, they don't go change the original entry. They put a new entry saying, hey, this is a correction to that old entry. So there is a complete recording of what happened when, by whom, and things like that, for auditing purposes and so on. So that's precisely how this blockchain thing also works. When new transactions get appended, no changes are made to pre-existing things that are already in the blockchain. So in order to detect any tampering where somebody is trying to misbehave, what they do is they compute the hash of each block, and in the next block, in addition to a pointer potentially being there, which makes block n point to n-1, block n also contains what the hash of n-1 is. Okay? And the idea being that if anybody modified even 1 bit in n-1 after it was originally created the legitimate way, this hash will not anymore match the hash you compute with the new version of that block. Okay, this is all, folklore these days about relying on hashing as a way of detecting any tampering. Of course, this brings into the picture all the things about SHA-128 and 256 and how much any of this is going to be withstood by quantum computing and that kind of technology. And we already know that 128 can be reversed. That is, you can cook up a way of modifying the page in such fashion that the hash is still the same and things like that, right? So this is all subject to, these other sorts of technological advances not screwing up this ability to detect such tampering and so on. But in general, this concept is called the Merkle tree, which allows you to essentially, by computing hash on one thing and that itself having a hash of some earlier thing and such, any tampering along the way can be detected is the idea. And I'll let you go into the details. So there's a paper that was published in the ACM Q magazine by Arvind Narayanan and his colleague Jeremy Clark at Princeton that gives you, from a historical perspective, even though the Bitcoin idea was something that came out in a paper around 90, I think. Where is it? I'm having a senior moment. No, sorry. Here it says Bitcoin 2005, but it's not. The date is somewhere here. First line, yeah, thank you, 2008. That is Satoshi Nakamoto, okay? So it turns out there are ideas from the early 80s which all got combined by this fictitious person or group of people that resulted in the idea of Bitcoin being proposed. But this is getting more into the nitty-gritty of the data structure itself, this Merkle tree and other associated exploitation of hashing and things like that. So you can go read that. In terms of money, as I mentioned before, many startups right in our backyard have been raising money through this ICO process. And they, of course, will tell you that this is a great thing because this is like crowdsourcing. We don't have to go please the guys on whatever that road is in Menlo Park. The VC firms that try to take away a big chunk of your equity, ownership of your company, and so on for the money they give you for seed funding and this and that. But it turns out, while it took off a great deal last year and a little bit early this year, suddenly there's been a dip in the money being raised through ICO process because finally the authorities, at least in the US and in some other countries, woke up and said, okay, there's a lot of sleazing going on here where, ordinary citizens' money is being ripped off by these guys putting out just white papers, not going through as rigorous a process as it's required when you are doing an IPO filing in order to reveal all the what's in your ideas or whatever systems you are developing or some prototyping that you have done and things like that. And so that resulted in certain declarations. For instance, it says the CFTs, the Commodities and Futures Trading Commission, declared that crypto assets will be treated as commodities. That's like, wheat and such, right? The financial, I forget what the letter C stands for, something enforcement network. So they said they're going to think of cryptocurrency or ICOs as money. And meanwhile, the SEC said they want to treat them, except for Bitcoin and Ethereum, the rest of the cryptocurrencies out there, as securities. And so consequently, each of these organizations said, I'm going to expect you to now give me all sorts of information about what you've already made out with your ICO and things like that. So this has put a damper on the number of such ICOs and such. But turned out Companies like McKinsey have put out a few reports recently. So this is the June one, which talks about some of the myths about blockchain. Blockchain is Bitcoin. Blockchain is better than traditional databases. Blockchain is immutable or tamper-proof. Blockchain is 100% secure. Blockchain is a truth machine. Because there's lots of hype around this whole thing. People say, oh, you know, with all sorts of shady people around, we can still do things where we have more trust. This is projected as a way of guaranteeing trust across a group of parties who are doing stuff with each other, even though they don't know each other very well. And this technology will certainly bring about more method to the madness. But in fact, not all of the statements are true. There may be some truth to some of these things, and that's what the details are. And I won't dwell on that. Now, getting to the more algorithmic aspects and technical aspects of all this, turns out there are many technologies that have been developed both in the distributed systems arena and the database arena, which is this next slide, which have a bearing on what goes on here. Believe it or not, late '81, when I joined IBM Research in San Jose, soon after that is when Byzantine agreement protocols were being worked on in IBM Research, right in my own lab, where people were coming up with clock synchronization algorithms and things like that. Danny Dolev and Barbara Simons and people like that, Ray Strong. Joe Halpern even worked on distributed knowledge and things like that. So it's not at all that new, the notion of some people misbehaving or nodes in a network misbehaving intentionally. And long before all the bad things that we all now know about viruses and this and that came commonplace. And of course, people like Leslie Lamport, another Turing Award winner, came up with this notion of, Lamport clocks and how to synchronize in an asynchronous way different systems activities and ordering events and things like that. A lot of those things are extremely relevant in this context. Of course, later came things like RPCs and transactional RPCs and also message passing systems with transactional messaging and queuing, as well as PubSub and, of course, event-based systems with distribution events and things like that. So, of course, the more even relevant stuff, even more relevant stuff is workflow management systems and business process management systems, where a particular activity involves a whole bunch of organizations, geographically distributed, even potentially across the globe and things like that. Many of those systems had certain characteristics that made them not so efficient or fault tolerant or not keeping track of all the things that were going on in a way where it made it easier for you to later on do some root cause analysis and things like that. So you can think of domains where some of that will be relevant. If some food poisoning happens and you want to figure out where what came from, when, and how it was transported, and what the temperature in the truck was when the transportation took place, could it be that the air conditioner in the truck had failed and that's why this food got spoiled and nobody did anything about it until some people consumed it and then they died because of this problem? Things like that, right? And then, of course, the cloud and the service-oriented architectures and so on came. A little before I joined IBM is when all this relational technologies initial work happened. I joined midway through the R-Star project, which was a distributed database project. So I myself had worked on two-phase commit protocols and their variations and such in order to more efficiently coordinate transactions across different nodes. So in an atomic way, you can do a distributed transaction that modifies resources in multiple places in spite of various failures, node failure, link failure, and disk failure. We also worked on, believe it or not, in Principles of Distributed Computing Conference back in '83, a paper that combined the Byzantine agreement protocols with this two-phase commit protocol. So in that sense, a lot of this has been worked on in bits and pieces over a long period of time. But of course, in the database arena, there was a lot of work that has happened for a long, long time on replicated data management and things like that, and also warehousing versus online transaction processing, how to do analytics on transactional data, whether you have separate systems to do them or more, as has become more common these days, the so-called HTAP systems, hybrid transactional and analytic processing, so that in a single system, you can do transactional short and sweet transactions that are your bread and butter kind of money-making activities, but also analytics on that latest data rather than having to move that transactional data from where it originates to a separate place called a warehouse, build different kinds of indexes, and then do the analytics on them. This means that the analytics are done on out-of-date data. But it turns out with the modern way of transactions being done, and also the advertising-oriented way of making money and giving you the opportunity to learn about related things and such, and try to do additional sales to you, involves having to more quickly react to more recent events. And that's the reason these HTAP kind of systems have become popular. And we ourselves in Almaden research at IBM have been working on such systems, and products have come out and things like that. And of course, there was a lot of other things that happened with the Web 2.0 revolution, which resulted in NoSQL and things like that coming about, and MapReduce by Google guys, and then Yahoo and others. And of course, in the context of the web, data privacy and such have become important, transborder data flow, and I'm sure most of you know about GDPR, which just came into force in Europe, and that's introduced lots of expectations on the part of people who acquire and manage personally identifiable information, other kinds of information that's protected by GDPR, having to be a lot more careful about what they do with the data that's entrusted to them by customers and such. And of course, transborder data flow restrictions have always been a big deal in Europe, and they have become even more severe with this GDPR. And all of this also has to do with when you have these, across the country kind of business processes, exactly how the blockchain technologies are even, implemented and leveraged, and where information is kept about what all is going on becomes relevant. So in that context also, this open blockchain where it's open kimono, everybody can see what's going on, is just not a very practical thing, okay? And then of course, with multiple data centers and the cloud, whole data centers disappearing and such are also important things. Terrorism, acts of God and things like that, what are natural disasters and such. So what are we trying to do with this whole blockchain notion in a more practical context than all this hyped up cryptocurrency and so on? Look at a scenario like what you see in this slide, where it's an import-export scenario. There are multiple players, importer, exporter, forwarding agent, the trucking company that picks up the package, takes it to whatever the means of transport that you're going to be using, whether it's airlines or ships and such. And then there are government authorities which are doing inspections, customs and such people, or FDA kind of people doing, or the Department of Agriculture checking to see that you are not transporting something live and so on. So while all of these systems, all of these entities may be using computers and or even exchanging electronic messages, this doesn't necessarily mean that it's all being done in a nice and coordinated fashion, meaning each of these entities has its own database where information is being tracked. They might be exchanging EDI or XML or JSON kind of messages, but typically they tend to be point-to-point kind of messaging. There isn't a coordinated protocol that ensures that everybody has a single source of truth, be it replicated. But right now, each is on his own in terms of the programs that they use to manage the data that they are keeping, even though the data that's being kept involves all these different parties and so on. To this day, there's a lot of paper documents also, and if things do go wrong, people, after the fact, modify these documents to try to shift the blame to somebody else, in the case of death or whatever, right? And those things are hard to detect, just because there isn't a method to the madness with which these things are being managed. Whereas in the blockchain way of doing business, which is depicted on the right side, what you find is that there's a single set of programs that are collectively developed by the parties to this business process, who then, in a systematic way, of course it depends on the use case, figure out whose blessing is needed before a state transition is made to the asset that's being managed in this fashion. As I said before, the assets could be purely digital assets or digital representations of physical assets like diamonds and packages and so on, right? And each of these organizations has a copy of the database, and it's the exact same copy. And people cannot willy-nilly directly go to the database and update it. It's these programs, these so-called smart contracts, which are being developed and which embody the rules of engagement between these different parties, that actually are the ones that are going to manipulate the state database in which these assets are being tracked in a persistent way. Separate from the state database, which has the latest state for all these assets, is this other data structure, which is the blockchain, which has the historical record of from time zero when this network was formed, this particular network. What all transactions have taken place. Some assets got created, some assets got destroyed, and so on and so on. And in the case of diamond, for instance, the diamond was mined, a raw diamond, and then it got polished. You had a big diamond, then it gets split into small ones, and then you sell it in wholesale and retail, and somebody buys a single diamond, gets it mounted on a ring, and presents it to his girlfriend or whatever. This whole set of transitions that are being performed on this asset, sometimes things are being split, sometimes things might be combined. Like collect a bunch of packages and put them into a big box. Collect many boxes, put them into a container, and then it gets shipped. And then again, at the other end, it gets split up back into the original components and so on. All of this needs to be tracked. You might say, hey, what the heck, don't we have tracking number that FedEx and so on gives? Guess what? They only give you a window into what they choose to expose to you. You are not able to actually see exactly what FedEx has in its database. So whereas this technology now lets you, in a more systematic way, let all the participants decide how they're going to do all this and codify it in the smart contracts. Of course, this means if you already had the pre-existing chaotic way of doing business, in order to get to this more systematic way of doing things, you do have to rewrite your programs and so on. And this is where the point I made at the beginning about no standards being there for this blockchain technology and all that in terms of API as well as the underlying conceptual model is going to be a problem until some of this gets fixed. Unless some of the dominant players in the scene today get enough of a market presence and the wherewithal to withstand for decades of the existence of that system, in which case you don't have to worry. And we have had these de facto standards in the past anyway. But again, these pieces of work are being done today in the form of consortia. So it's not as bad as the NoSQL space where every 3 or 4 guys get together, develop a new system, and who knows how long it will last and so on, because these 3 guys might shut the garage and decide to make really money to feed themselves rather than doing this open source development and doing charity kind of work. But now, in the blockchain space, bulk of the activity is being done in the form of consortium. So now you'll see flowcharts like this being shown. This is the way you decide, given your particular use case scenario, is it appropriate for you to implement this use case scenario using blockchain technology, or should you just deal with this using traditional transaction processing databases and so on, DB2, Oracle, whatever, right? It turns out this particular one put out by the World Economic Forum has a bug in it. They make it appear like you cannot deal with physical assets using blockchain technology, and that's completely wrong. I've already talked about that before. But IBM also has a similar kind of chart that's used to go help customers, groups of customers who are trying to evaluate the applicability of blockchain technology to a particular use case scenario. The notion of smart contract I already talked about. It's the generalization of the Bitcoin to any kind of asset and so on. So you can talk about taking a natural language contract and transforming it to a more formal contract and being able to prove certain properties. Those of you who are into simulations and this and that might be aware, or business processes, that for a long time P-tree nets used to be used as a formal mechanism to model multiple activities, some of which could go on in parallel, some of which have to happen serially and such, trying to prove deadlock-free or liveness kind of properties of such networks. Similar things are being talked about here. And then you might want to take that formal contract in which you have proven certain properties and then come up with an executable contract. Okay? All of this is being researched on right now. Okay? IBM has a long track record in this space. I already mentioned the fact that we developed originally a prototype and then open sourced it and formed the Hyperledger Consortium in order to make other people also become part of this effort. And that's how the Hyperledger Fabric project came into existence. But since then, other projects have come about, and IBM has this blockchain as a service offering and things like that, and on and on. So this is the offering that we have now, where on top of the IBM Cloud, you have the Fabric, which is the base platform. On top of it, a much more recent project that got initiated, again with IBM, doing the initial work and then open sourcing the software, is the Composer that lets you more easily develop the use case on top of the Hyperledger Fabric. This is like 4GL tools that used to make it easier to develop database application. You can also, do your own work and develop the app, but this makes it easier. It turns out the problem with dealing with physical assets and modeling them using blockchain is that if you had the real diamond at one point and along the way somebody substituted the real one with a fake one, how the heck are you going to figure this out? Because all that hashing thing that I mentioned will be useful when the online stuff gets manipulated illegally, right? Then you can recompute the hash and it will look different from the original hash. How do you deal with it when it comes to diamonds and olive oil and high-end wine and so on? So that's where IBM more recently came up with this technology that was developed in the research division, which has to do with what's called the crypto anchor verifier. So just like you have fingerprints for humans, it turns out, depending on what material you are looking at, for diamonds, for instance, the inside of the diamond has a signature which is unique for different diamonds. And so this attachment to a mobile phone's camera is a fancy microscopic lens which can be used to measure various physical attributes of that physical asset. Even things like viscosity and things like that, depending on whether it's a liquid or what and such. Saturation values, spectral values, and things like that. So even things like QR codes, which to the naked eye or when you photocopy might appear to be a continuous line, is in fact not a continuous line. This is no different from the different technologies that people have used to make, for instance, forging of currencies almost impossible, right? It's that sort of thing that can be used so that when you know something legit is leaving the factory or whatever, you create its crypto anchor, the signature, and then you stick it into the blockchain. And later on, if at some point in this chain of transitions that are happening, or transactions that are happening, if somebody does do a substitution or somebody wonders whether what they've been given is still the original thing or not, they'll compute its anchor and check against the blockchain to see are the two matching. That's the idea, okay? And it turns out this involves artificial intelligence and imaging technologies and such because it's not like an exact match. Because if you're dealing with, let's say, I don't know, mangoes and such, over time, the mango could undergo some chemical change which causes its weight to change. So if you are using weight as the crypto anchor, you better do approximate computation than exact matching and things like that, okay? This just tells you how, using a blockchain as a service offering makes life easier for you than if you were to download the open source software yourself and install it on your own machines and get going. Turns out the blockchain as a service offering has certain features that make it easier to use, also certain reliability features that are not part of the open source and such. And also, IBM found that even with the blockchain as a service offering, getting going was a bit hard. And so they came up with something called the starter plan, which very quickly lets you, out of the box, set up a two-node network with this consensus protocol being handled by a single node. Today, it turns out in the software, for those of you who know about such things, Kafka is being used as the ordering service. This is the messaging and queuing system, open source one, similar to MQ series that was done long ago by IBM. That sort of thing will very quickly let you try out a small configuration. And then if you want, you can get sophisticated and add more nodes and things like that. So as I said at the beginning, the IBM blockchain as a service offering runs on the mainframe. Maybe some of you think, oh, mainframes are dead and what the heck is he talking about? And you are completely wrong. If you still don't know that the mainframes are being developed and enhanced, you better take note. There are still lots of money being made and all that in the mainframe space. In particular, the mainframe has certain hardware support for encryption and such to speed up things, as well as this notion of very secure way of executing computations and such, which allows these so-called secure services containers to execute not only the smart contracts themselves, but even the base platform in a way where even the operators of the system cannot tamper with the code or listen to the data that's being exchanged. So it's a high level of security, and IBM knows and is proud of the fact that this is the most secure way of doing things anywhere on Earth. And it turns out the Intel SGX has certain aspects, but it has a lot of limitations on the resources that you can put under this. So only the smart contract is typically executed in the Secure Execution Enclave, SGX, but the base platform itself cannot be executed under it because the amount of memory and disk storage that can be put under the SGX umbrella is very limited, and there are people in Berkeley at the Rice lab who are also working on these things. Ralu and such people. She's a professor there. In terms of components that are part of a blockchain network, you have organizations which have nodes, and then there are people within the organization who are individual users, and there are different privileges associated with these different entities. Exactly who can initiate what kind of transaction, similar to database systems and so on. There are different kinds of players, and we'll see soon. Remember, this is in a private blockchain environment, which means only people who are trusted will be allowed to become part of the network. And even then, only people who have a reason to be there because they are participants in this business process. How is all this accomplished? There are certificate authorities which issue certificates who know the identity and so on. Think of Uber and Airbnb kind of a scenario. Would you be really happy, as the open blockchain people would like you to believe, that you would be willing to deal with any random person out there where you don't know the identity of the person? All you know is some address or a number, and nobody knows who's behind the number. Clearly, we want accountability and such, right? So even if we as individual users of Uber don't know all the gory details of the person that's coming to pick us up, we know that the company Uber knows a great deal of stuff about that person, the real-world identity and all sorts of stuff that they've checked out and so on. Yeah, even there, of course, there are some bad people who try to get away with, in some cases, literally murder. But then, the law takes its course and fixes these problems, and soon they get booted out of the system. So similar things are done here. The point being that in a network where you know the parties, the chances of some people misbehaving are a lot less than in an open blockchain environment where anyone, anywhere, willy-nilly comes and goes and such. And it's because of that aspect that the open blockchain go through a very painful, expensive, time-wise, resources-wise process of trying to validate by using this proof of work and other consensus protocols. That makes it awfully expensive. And also in this day and age of green consciousness and so on, it's really mind-bogglingly dumb to waste so much energy and such. Yeah, some of the hardware vendors are happy, TSMC included, because they made some money building these special purpose things and so on. But as a society, it's not at all right for us to be spending so much, wasting so much energy, and also cooking up something that's like making something out of nothing kind of thing, which is this notion of a money being created with no real relevance to real-world productivity and goods and services and such things. Okay, so we'll get into some of these details. So similar to in a database system, you have players like application programmer, system admin, database administrator, and so on. In this context also, roles have been defined. So you could be a blockchain architect, you could be a blockchain developer, a blockchain network operator, which in this case of this IBM blockchain platform, it's IBM, and with the Oracle Cloud Service, it'll be Oracle or Huawei, and so on. You also have the individual blockchain user, who may be a clerk within, let's say, Safeway, right? Or somebody that procures vegetables for Safeway, and so on and so on, right? There's Safeway, there are farms which are supplying stuff to Safeway, those are organizations, right? And then you have this membership service thing, the one that issues certificates and so on. And then you have still access to traditional database systems and back-end transaction processing systems. Because I might accept an order through the blockchain way of doing business, but the actual fulfillment of the order in terms of manufacturing whatever needs to be put together, or joining a bunch of stuff, configuring something, that can be done through traditional means of pre-existing software, whether it's SAP or some other manufacturing system or whatever. Once that article is ready to be shipped out, then you come back into the blockchain way of doing business and say, hey, okay, I'm done with producing this. Now let's go send it to the people who asked for that item. So what does the composer let you do? It lets you more easily define the elements of your solution, which has to do with what the assets are, diamonds, packages, and so on, what the transactions are that you can perform on the asset, which is like polishing the diamond, breaking it, and such. And then there is associated logic to implement. This is no different from the priest who asked the groom, are you willing to marry this woman? And asked the bride, are you willing to marry this man? And then declares, okay, this marriage has now taken place. That's a state transition. And the rules that are being enforced are these questions being asked of the two people. It's those sorts of things that are associated with each state transition and whatever the asset is that you are managing using the blockchain. And so the smart contract itself codifies these things that you have to get asked about and agreed upon before you are allowing that transition to happen. And all of this is done in a way where the different parties who are consulted, who give their blessing and such, will certify that they agree to it. And this is what that makes it very easy to later on prove. When somebody says, oh, I didn't actually give my approval, you flash the approval that they gave because their signature is there, the digital signature and things like that, okay? And then you have the participant registry. These are the people that I said who have the privilege to execute these different transactions and so on. And that's no different from access rights management in a traditional database system and things like that. So it lets you define this model of your particular use case nicely, and then you can develop the thing to be run on the Hyperledger Fabric platform. As you can imagine, this could be generalized so that instead of the target being just the Hyperledger Fabric, it could very well be something like R3 Corda or Hyperledger Sawtooth or some other kind of blockchain system. But today, it's restricted to only working with Hyperledger Fabric. So remember I said you might be a pre-existing set of entities that are already doing things with one another in that chaotic fashion that I showed in that initial slide. And I said, hey, in order for you to benefit from the blockchain way of doing business, where you have much more accountability and tracking and everything, you need to come up with these smart contracts and such that are collectively defined. And I said, it is a painful transition you have to undergo. There are various ways of skinning that cat. Instead of everybody that's an organization that's a participant in a particular blockchain network sitting around the table and collectively defining the smart contracts, what they are supposed to also enforce and so on, it's possible that the big wheels in the network, namely, let's say, Safeway and Walmart, they get together and decide what these things are, and then they let the minions just merely take those things and install them in their shops, the minions being the suppliers and so on, right? Or you can be more democratic and everybody actually sits around the table and does this. Or you could have, as it happened in Canada, where a bunch of banks wanted to do the know your customer kind of application. Instead of doing the work themselves, they decided to let a startup do all the work. Secure Key is that startup which implemented this know your customer application for these 4 or 5 Canadian banks to work together. So this is just telling you about these sorts of things. Turns out there are many, many use cases. I've already rattled off a few that have been working on this for more than 2 years now. Some of them more recently, some of them for about 2 years. And there is even a book that talks about, how the blockchain technology has the potential to become like the next coming of the internet in terms of the widespread impact it can have on society, not just your and my kind of people, namely geeks, but for the man on the street kind of people. How once the internet got going, ordinary people benefited a lot from the fruits of the labor of all the techie people. In that sense here, many domains can be impacted. So there's lots of stuff here about what are all the different kinds of use cases in which it's been adopted. I have a few slides. There are also opportunities by industrial sector in terms of the feasibility, low to high versus impact, which is low to high, that McKinsey has come up with. I'll let you guys see all this at your leisure. In the food space, I already talked about, how things happen, how when there are some major disasters, food poisoning and so on, today, mass recalls are done, E. coli or whatever, right? Whereas with this blockchain way of tracking things, you can have more targeted kinds of recalls because you know exactly from which farm this particular dishes ingredients came from, and as a result, only those people who bought the stuff that was produced by that farm need to throw away whatever they have in their freezers and so on. Same sort of thing with, in the case of global trade, shipping, the world's largest shipping company, Maersk, which is a Danish company, they have been working with IBM for about 2 years now, tracking packages. It turns out there are an unbelievable number of entities that are involved when a container goes from one country to another and with its all component boxes and so on. And they have a hard time giving real-time information about where things are at any given time. And so increased speed and transparency for cross-border transactions through real-time access to container events and such. There are also organizations like the Singapore Port Authority, which wants to get into the act of deciding dynamically based on actual ships' arrival times and so on, to switch sending a particular container from the original one that they were going to ship it in to a different one because they noticed there's a delay and things like that. So instead of the shipping companies themselves getting into this, the port authority wants to maximize the use of the space in the port itself and provide better response to customers and so on. Governments are very eager to leverage this to reduce corruption and also make life easier for the citizens. So Dubai wants to become completely paperless with respect to government work by the end of 2021, although the thing says 2020. That was their original target. Abu Dhabi and Dubai are competing with one another like crazy in adopting blockchain technology. So the idea here is you walk into the office, you prove who you are with biometrics because you have a card which has your biometrics. Once you have done that, this government office in Dubai at which you are trying to get some service will know your full story, who you are, what your salary is, how many kids you have, how old you are, blah, blah, blah. You don't have to be supplying all those documents every time you wander into an office. You are eligible for this being free, that being given to you at 50% and so on. Similar stuff with IBM and FDA working together. So they want to focus on oncology data, tracking exactly who gets to see it and who actually was provided that information and so on. So maintain transparency in what data is going where and things like that. Secure weak spots in sharing process. HIPAA regulations are very important in this space, healthcare space. As I said, lots of work in the form of consortia. The latest consortium to come into existence, which was already early last year, was the Enterprise Ethereum Alliance. Long before that, the Hyperledger organization had come into existence. This picture shows you what some of the elements of the system are in any blockchain system, private blockchain specifically. The top is the blockchain data structure, which is the sequence of blocks. It turns out based on some of the things that were done with this proof of work that I mentioned, it's possible that multiple people might win simultaneously the competition that's set up to determine who gets to add a new block. And as a result, in an open blockchain, the chain might have been really a linear chain and suddenly there is a fork. It's like multiple versions of software being developed from the same base, right? Diverging versions. And this is a nuisance. This is part of the reason why that 10-minute per transaction kind of response time is there. Because now these two forked branches could keep going forward. And they try to sort of incentivize people to make the longer fork be the ultimate winner and declare that the shorter fork is the loser. And this is the reason you have to wait for a fair amount of time, and even then it's only asymptotically guaranteed, not 100% guarantee. So there's all this, if you like, non-deterministic behavior in the case of open blockchains, and we get rid of all that with private blockchains by making it completely deterministic. But in any case, exactly who gets to add a block and when and so on is determined by the so-called consensus protocol or layer, and that is the proof of work, proof of stake, proof of asset. And IBM and its partners used to use what was called practical Byzantine fault-tolerant algorithm that was developed by Barbara Liskov, the second woman to win the Turing Award at MIT and her students. But in the latest release, 1.0, the Fabric guys decided in the interest of performance, they are not going to worry really about Byzantine behavior, and they went to this using Kafka as the way of doing this consensus layer. Even the execution of the smart contract and the language in which it's coded, there are variations across different systems. And it turns out because of the particular way in which these transactions get executed in a blockchain, all sorts of restrictions are placed on what you can do in your smart contract code. Namely, it cannot be a Turing complete kind of language, because that can result in things like tossing a coin and looking at the position of the moon and so on to be done, which if the same contract is executing on behalf of a single transaction in multiple locations could result in mismatches because it's not deterministic. So various constructs like that, RAND function and so on, are disabled when you specify a smart contract by restricting the language features that are available to you. Also, in terms of the database in which the asset states are being persistently tracked, as opposed to the blockchain data structure, there are variations. Some people use relational databases, some people use key value store and things like that. So in general, what you'll discover is that for various architectural features, different systems have made different choices, and they haven't bothered to really, in a very systematic way, justify why they did what they did and compare and contrast these different choices made by different systems. There is a start that was made in this paper that I've listed at the bottom. You'll get the full reference in that page I gave you the link of at the beginning. But this is the reason I said, one of the reasons, that there's scope for a lot of interesting work to be done by researchers and people looking for thesis topics and things like that, or even companies that want to provide certain features to give you the ability to evaluate different systems with respect to certain features and so on. So if you're trying to look for startup ideas or new projects, even in established companies, there's lots of stuff that can be done. In terms of comparison with database systems, distributed database systems with replication, turns out there is less reliance on all that tracking and such being done in a very methodical way in a traditional database system. As a result, a transaction might start in one place. Once it gets executed there, then its effects are propagated to other copies. So there's a notion of master copy and then slave copies. Because of that way of doing business, where there isn't this idea of these are different organizations and you can't do something unless multiple of these organizations that are party to the particular transaction give their blessing. The blockchain way of doing the same thing becomes a more elongated process, even in a private blockchain. And hence, performance is not the same as in a traditional distributed database with the notion of master copy and then slave copies. Because the master copy gets updated, and with less expense, you are then able to propagate it to the other guys. There are more details I can get into if you're interested as to whether you just rely on the log record from the master to replicate the changes, or from the master's log records you generate SQL statements or some high-level database constructs, and then you re-execute them in the other places. Because the second way of doing it allows you to have different database systems and with different page formats and so on. Whereas the first way of doing it, where the log itself is processed as if you are in a restart recovery mode, means the configurations and the system version and everything has to be exactly the same. It's as if this node itself crashes and comes back and uses its log record to do restart recovery and provide transactional atomicity. So that is a lengthier, very deep technical conversation. We can have it, and I've discussed it in some other presentations. So I welcome you to go look at some of my other videos also. This is the one that is again based on work done originally at National University of Singapore with their collaborators in even mainland China, where they came up with the first blockchain benchmarking framework, similar to some of the things that have gone on that many of you probably know about, which is the Transaction Processing Council, which came up with TPC benchmarks, B, C, D, and so on, which have been the bread and butter of how different vendors' products, DB2, Oracle, and such got compared, and hardware architectures also, Power machines versus Intel machines, and other RISC machines and such. So these guys have combined elements from the OLTP benchmark and the OLAP benchmark, online transaction processing and online analytic processing benchmarks, to come up with elements that exercise different components of a blockchain system, namely the application layer, the execution engine, the data model, and the consensus layer, and things like that. And they did some comparison initially, but what they did initially is not so important, but the idea behind this is what is more important. And they made the architecture also pluggable, so even other systems that they didn't evaluate could easily be compared by, developing something that is consistent with their pluggable architecture, APIs, and so on. The Hyperledger Caliper project is a much more recent activity, which is in the context of the Hyperledger Consortium, trying to do these sorts of things that the university guys had done. You can think of this as maybe, baby steps towards forming something like the Transaction Processing Council, but it's still in its very initial stages. There is a comparison of Ethereum, Fabric, and Corda. Ethereum being the still open blockchain, but follow-on to, if you like, Bitcoin that I said generalized the notion of what the assets were from just a single currency to any kind of asset. Fabric I've already talked about. Corda is a completely different kind of system that was developed by a bunch of banks that wanted to, in the banking domain, have as part of the conceptual model of the blockchain even more specific things that were relevant in the financial domain. And so this is where I said the conceptual models themselves are different between these different systems. There are certain features in Corda that are not there in Fabric, because the Fabric is a very simple, basic system, but you can add anything you want on top, but you have to program those things. But the Corda guys, since that consortium was formed by a bunch of banks, they made it extremely specific to the banking domain. I've already discussed some of this, Ethereum, and how it still has many features similar to Bitcoin, and hence performance is also a problem. It has its own currency. Unlike Bitcoin, it has something called Ether, and also they have a way of charging for time by having something called gas. But the more interesting development is the Enterprise Ethereum Alliance. The JP Morgan guys developed in-house some system that they were using initially to do blockchain, which was adding the private blockchain aspects to the public Ethereum blockchain. And then they decided to open source it. And for a while, it was believed that Quorum will be the basis for Enterprise Ethereum Alliance. But then over the last year or so, there was a lot of confusion about exactly where EEA was headed. Ultimately, it turned out they decided to not have a single system as part of EEA, but let 1,000 flowers bloom kind of thing. So Quorum happens to be one of them. And it has its own way of doing things that are not necessarily the same as how Fabric has evolved over time. And I'll come to what that is, which is, remember, in an open blockchain, anyone, anywhere can see what's going on. And they can come into it and go out of it without having to even announce the fact that they got in and they got out and so on. Which also from a scalability perspective is mind-bogglingly inefficient and makes it really, really performance-wise bad. Apart from the fact that everybody gets to see what's going on. Imagine, even in a private blockchain network, it turns out if you have Safeway and Walmart on the same network with presumably lots of common suppliers, also some suppliers that are unique to one or the other, Walmart doesn't want Safeway to see what all goods it's buying, when and at what quantity and so on. And the other way also, right? This guy doesn't want that guy to see. So they said, hey, in a private blockchain, for instance, in Fabric, in the 0.5 and 0.6 releases, once you got admitted to the club, allowed to be part of a private blockchain network, you got to see everything that was going on there. Even that they couldn't, just let go. They said, we want more privacy than that. So the notion of what's called over there in Fabric, channel was introduced. You all know about Venn diagrams. Essentially, you have a set of items. You can now define subsets with potentially overlaps, right? And each subset is called a channel. So even though there is a single blockchain network, with respect to each channel, you have its own blockchain, its own state database, and its own smart contracts. But what's common is that the identities are all the same and so on. So I and Jeff could be part of one channel, but I could be part of another channel with somebody else. And then there could be a third channel which involves all three of us. Because there are certain transactions where the three of us are involved, but there are certain transactions that he and I do, and certain transactions that I do with somebody else. So now you have complete disjointness with respect to what happens in the context of a certain channel. Whereas these guys, in the quorum way of doing business, they did it differently. They said there are certain things that are common across all the nodes. They call that the public state that's visible to everybody, that gets described in all its glory in the blockchain data structure. But then there are some of these things that are private to a subset of the people, and then they, in the blockchain, don't describe the details of such subset transactions. Their state is kept in the state database, in the private state database. So you see some blue and different colored things. So only the guys who are allowed to see a particular transaction's activity have a copy of that transaction's states that were created. The problem with this is that in the Fabric way of doing business, the whole story is in the blockchain. So what is in the state database is merely the latest state of all the assets that are talked about in the blockchain. So you can easily blow away or even if it gets blown away, the state database, you can, in a laborious way, go through the whole blockchain and reconstruct the state that was the final state of each of the items that's still in existence that is reflected in the state database. Whereas with this picture, it turns out if one of the blue ones is blown away because the drive crashed or whatever, you cannot now just go into the blockchain because blockchain only has hashed version of the information. It doesn't reveal the full details. And so you really have to go to one of the other guys who still has a copy of that thing and get it. And this is, in some ways, inconsistent with how things have been done so far, where you don't rely the other guy to give you directly the current state. You rely on this data structure, the hash-based way of doing things and all that, that's part of the blockchain to know that what you are getting is the legit version and not some tampered version, because the state database itself doesn't have the exploitation of the hashing and so on. So anyway, there's a lot of detail, but so the Hyperledger, as I said, has many projects, the Fabric having been the first one, another one being the Composer that I talked about that IBM contributed, but there are others which were initiated by other companies. In particular, Hyperledger Sawtooth was initiated by Intel, and it's still the major contributor to that thing. And there are even more things like a Burr, Hyperledger Burr and Hyperledger Indy, which have to do with taking the Ethereum virtual machine that was developed in the context of public blockchain, taking those contracts and executing them on the Hyperledger Fabric. This is a way of leveraging the talent pool that's out there that's very knowledgeable in the so-called Solidity language in which smart contracts are implemented in Ethereum. And so there aren't as many people that are out there for the Go language in which, to begin with at least, smart contracts were to be implemented in Fabric. Now Java is also being supported. So it's all a point-in-time statement and also giving you some level of portability from Ethereum to Fabric that's currently ongoing. There are lots of details, I won't dwell on them. It turns out, as I said a few minutes ago, the major change going from the pre-1.0 release to the 1.0 release was the introduction of the notion of channel to provide you additional isolation in terms of who gets to see what, but also providing you additional scalability, because now transactions across different channels can go on in parallel, and hence you can scale better. But also, there are a few other things that were introduced. I won't dwell on them too much. But currently, there's a great deal of momentum behind the Fabric because it's not just IBM that's behind it. But as I said, Oracle has announced support for it, and there are other Chinese software houses that also have adopted it and so on. So it's in a much more mature state from an industrial strength viewpoint and things like that. So in terms of details as to how things work, when you have an application that's running on the client side, which is initiating a blockchain transaction, that is essentially an invocation of something like a stored procedure smart contract on the server side, where some input parameters are provided. It could be a state transition like you bought a ring, or you mounted a diamond on a ring that didn't have anything on it, and so on. As the smart contract executes, it makes calls to the database system, which is the one where the current set of assets are maintained, and you are attempting to read the state there and also modify the state there. It turns out in the initial stage of executing a transaction, no updates are actually performed. Only reads are performed directly in the database system. Any writes that the smart contract wants to perform gets cached. This is the so-called optimistic concurrency control way, for those of you who know about database systems and locking-based approach versus optimistic concurrency control. So this is a simulated execution of the transaction in which you are trying to determine each transaction's read set and write set. And this is where the inefficiency of the blockchain way of doing things comes, because while it's going on one node, any other node whose blessing you have to obtain in order to permit this state transition to go through would also be simulating the same transaction. So in parallel, multiple entities, the so-called endorsing peers, will be performing this simulation of the transaction. While this is going on, event notification can happen, because a single smart contract might invoke another smart contract. It's like abstract data types. Each smart contract owns certain piece of data. If one smart contract wants to look at another smart contract's data, it cannot directly access it. Instead, it has to invoke a function in the other smart contract to read or write that other smart contract's data, exactly like ADTs. And so these are the notifications that might happen. A transaction got initiated, it did this, it did that, and so on. At the end, when control goes back to the client, that designates the end of a blockchain transaction. So ideally, we want to execute a single blockchain transaction as a single database transaction, okay? But turns out, because a lot of these systems have used some flaky NoSQL database systems as the underlying state database, they don't typically have full-blown transaction support. All sorts of accommodative things had to be done on top, which have reduced concurrency and things like that. And as a result, the transaction throughput is not as good as it could be. So these are the sorts of places where database guys like me get involved and try to fix up things to improve the story and so on. That's my ongoing project. I won't talk about it right now, but so the idea of this, some nodes being designated as endorsing peers and other nodes as ordinary peers, is another change that was introduced in version 1 of the Fabric. So I'll get into that in a minute. So diagrammatically, so what you see on the left is the blockchain, which is very much like a recovery log, as I mentioned before, but it has more stuff in it than a typical recovery log, because recovery log only has writes in it. Here, even the reads are being recorded. And the state database is where the latest states of the assets are being mentioned. People will tell you, oh, this blockchain is an immutable database, and once you put something there, it stays there forever, and that's the bad aspect of blockchain, and hence we want to keep some of the sensitive information off the blockchain in a regular kind of database, and only keep the hash of what's in that regular database in the blockchain. This is now like a half-assed way of, compromising on what you thought you were getting out of the blockchain by going back to the traditional database way. people don't typically address who's the one guy who's going to manage this off-chain database. Why is that one person special compared to all the other, peer-to-peer kind of thing that we all were bragging about as the good thing of the blockchain way of doing business? Also, all it lets you do is, if somebody mucks around with this in an illegitimate way, and hence the hash changes compared to what the blockchain says is the legitimate version of the document's hash, you just discover that it's been tampered with, but you don't have a way of getting to the original thing. Whereas in the blockchain way of doing it, because there are multiple copies and so on, even if one is messed up, you can go to the other one and get the original version. So some of these sorts of things are still in a hand-wavy way dealt with by people who say, oh, blockchain might not be appropriate for sticking huge documents. Hence, I'm going to keep it in a regular database, in an off-chain database, and then on the chain only keep the hash and things like that. Okay, so there are many things like that that one can talk about. And there are indexes, very simple-minded indexes that let you get into this hash chain and the blockchain data structure. This is something that you would need to do if you're interested in doing analytics on the past states of these assets, not just analytics on the latest state. But even the latest state, if you want to do analytics, if this is a Mickey Mouse database like a NoSQL, which doesn't have the full power of SQL, that's also a nuisance. This is why you might have to extract the data from this Mickey Mouse database system, as I call it, and have to stick it into a real industrial string database with more powerful APIs and so on to do analytics. Which is harking back to the traditional OLTP versus OLAP kind of database system, which has lots of issues. And ideally, we would like to make this a more industrial string DBMS with all sorts of fancy features, which is a HTAP database system where you can do in-place analytics. And of course, there's no reason why this cannot also contain the historical states. Right now, it contains only the latest state, but there are bitemporal database systems and transactional SQL and so on, temporal SQL, which allow you to even do queries that involve state changes themselves. And because this is not a real database system, this is just a sequential file. And so doing anything on this is a pain in the where. There's lots of, for database people to work on. So the three-staged execution of a transaction in the blockchain, in the Hyperledger fabric specifically is, like here. So initially when the client is invoking a blockchain transaction, as I said, what I showed in that earlier slide was the execution that happens in one node. But the transaction is actually submitted to more than one endorsing peers. This is where you are trying to get their blessing and so on for the state transition. This is the simulated execution, which results in read and write sets being determined. And then they get sent back to the client, who compares what it got from multiple people. And if they are all in agreement, then it says, okay, this transaction can now be scheduled to get executed in its true form. Because no updates were done in that simulated execution. Nothing is remembered by those endorsing peers of the fact that they started the execution, did the simulation, and sent back something. It's amnesia time for them once they finish the simulation. This ordering service is a simple-minded thing in this system. Unlike in the open blockchain world, all this guy does is it receives a bunch of these transactions with all the signature and the read and write sets and so on, and puts them in some random sequential order, one transaction at a time, produces a new block, and now ships it to everybody, including the original endorsing peers as well as the non-endorsing peers. In any given transaction, only a subset of the endorsing peers might have been brought to bear on the simulation. That's all decided by the client. What do each of these guys do when they receive a new block of transactions? They step through one transaction at a time. They pull up the read set. They peep into their own databases, the state database, check to see, are the items that were originally read in the simulation still in the same state? If they are, then that means that the validation has succeeded. At that point, they just take the write set and dump it into the database. No smart contract execution, nothing at that point. It was all done only during simulation. And that's the reason these committing peers don't even have the smart contracts installed in them. They are merely tracking the state changes for the successful transaction. Presumably, those nodes will be used to do analytics and such things on them. They are also not necessarily aware of what the rules of engagement are, and that's also considered somewhat of a secretive thing and things like that. Maybe a trade secret, whatever the thing is, right? So the point is, it's only in step 3, if validation succeeds, that this transaction actually is declared to have successfully executed, and hence its results get put into the database. And that is a committing of the transaction. As you can tell, there is this lengthier process that you go through in order to realize the effects of a transaction in a persistent way. The idea is that in step 3, these nodes themselves won't be talking to one another, peers, but they'll all still arrive at the same result. If the transaction fails validation in one node, it would also fail validation in all the other nodes, is the assertion. What does failing validation mean? That means that one or more of the items that were originally read during simulation have changed meanwhile because of other transactions that could have executed in between, and hence that transaction is declared a loser transaction. None of its changes is incorporated in the database. All right? It turns out this model of executing transactions is quite different from the way the other blockchain systems do it, as well as even in the fabric. Prior to version 1, this is not the way the transactions got executed. Prior to version 1, all transactions went to everybody in the network, and they all went through the same set of steps, and that meant that it had to be deterministic. And it was expensive, and also in the open blockchain, you didn't even know who are all out there. So it was more like a propagation that happened at its own pace and so on, and each guy sent it to his neighbors and such. There was no global knowledge of who all was out there and so on. So there are more details about all this if you are interested in the geeky aspects of this in that paper that I've cited there. And also, in terms of the endorsement policy, which is how does the client decide how many people to send it to, and what do each of those guys have to agree to or not necessarily agree to, that determines whether or not you go from step 1 to step 2, is all left up to the designers of the solution. And so we give you a way of giving a specification, which could be that Jeff is an important guy, so he has to bless every transaction, but amongst the other 4 people that were consulted as the endorsing peers, it's enough if a couple of them are in agreement. That sort of policy specification is what this endorsement specification is. There's a lot more geeky details, and there are various database aspects to this that are also painful, because now the layer of the fabric that sits on the database system that's doing the simulation thing has to understand the database APIs and so on, and this will get to be really hard if the API is not this simple-minded key value store API, but it's actually a more powerful SQL kind of database API and such. So I'll just flip through the rest of the slide just so that you know what's there. I talk about the R3 Alliance and the Corda system that actually leverages relational databases, and it has the notion of on-chain and off-chain and such. They even operate behind the firewall and things like that. They have higher level concepts because, as I said, it was developed originally in the context of banking sector, with a bunch of banks getting together to form this consortium. So they have some of the financial industry kinds of elements as part of the architecture. It's as part of the conceptual model of their system itself. Cash and bond contract and cash contract and things like that. They even keep track of, over time, how different transactions caused subsequent transactions to come about, transaction history, if you like, dependencies between transactions. Such things don't exist in the fabric. Sawtooth relies on SGX and such. It's a way of also doing consensus that's different. It's called POET, proof of elapsed time as opposed to proof of work. They have certain features that lets them do more than one transaction in a given block that have conflicting data associated with them. It turns out in the fabric that validation succeeding or failing that I talked about has the bad aspect that if in the same block you have multiple transactions which got simulated in parallel, which happen to read and write the same piece of data, then simulation would have succeeded. But then at step 3, only the first of such transactions will succeed and the rest will get blown away, because the first guy's success means that the state would have changed for that particular piece of data, which these other guys also read the original version of. Now they'll realize, oh shucks, that's not anymore the current version. So concurrency is affected by that. Microsoft has done something. This is a repeat of that original slide that I showed, which said many architectural features had different choices being made by different systems, but there is no rationalization and all that. The project I'm doing right now is replacing the get, put, delete kind of key value store APIs that are being supported in the fabric today, and hence it makes the job of the writer of the smart contract be very painful, because this is like harking back to 40 years ago way of doing things, in terms of the richness of the model that you are having at your disposal to model the assets. You have a primary key and then a bag of bits. The interpretation of the bag of bits is left up to the application. The database system has no knowledge of the structure of this, which is even worse than ISAM and VSAM files and even IMS kind of database system, which is pre-relational, where you have not only the primary key, but many other fields that are individually named, typed, and such, which you can refer to in your manipulations and such. Lots of open problems, as I said, which can be the source for projects in terms of, or products, both research kind of things as well as technology developments, and lots of places where you can go to read up on other related stuff I've presented, and videos as well as PowerPoints, and also keep up with this topic if you are interested by following me on various social media accounts. Thank you.
Thank you very much, Mohan.
Welcome.
I think we have time for a couple of questions if someone would like to ask a burning question after the tutorial. Obviously, he'll be here during the coffee break, as well as I offered him a free lunch, so he'll be here for lunch. Are there any questions from folks in the speaker?
Sure.
So please. Please state your name and affiliation before your question.
Sarah Biabani, GridCom. A comment and then a question. So you talked about various areas of application, and one big area right now is the energy markets and transactional energy that you might want to add.
Yeah, I mean, it's actually, by the way, I should point this out. You might or might not have observed the fact that the numbers were not sequential. That's because if you go into the non-slideshow mode of this presentation, you'll see lots of slides that have been hidden, okay? So energy is definitely an area. There are people who are doing all sorts of interesting things with blockchain technology and combining it. In fact, I was in Aalborg in Denmark in April giving this presentation, and they also organized, separate from a 2-day event, where I was teaching the PhD students, an event where other people also presented. And the professor who hosted me, he is working on energy management and all this, home-generated energy and such, using blockchain technology. And there are also people who are dealing with carbon credits and such too.
Great, yeah. So the question now, so you mentioned, we are computer architects, we want to know the performance impact of all of this. So
right.
You mentioned the comparison between different blockchain implementations, but in the context of IBM's implementation of your Hyperledger, have you done any comparisons of the blockchain methods and traditional methods, especially regarding server compute impact and the network utilization and database size and all those kind of stuff?
So that paper that I pointed to, where I said there are a lot of technical details about how transactions execute in the fabric, It's actually a 22-author paper. It was published in April at Mohan Operating Systems kind of conference. That has some performance numbers, but the way they did the comparison was more between open blockchain and private blockchain. So they essentially simulated Bitcoin in Hyperledger Fabric. Okay? As far as I know, the kind of hardware thing that you might have in mind has not been done. Running the Hyperledger Fabric on, let's say, the mainframe versus on Intel or some such platform. That sort of thing has not been done. So, like I said, we are now at the stage where relational databases were 40 years ago. These are just the initial stages of production-grade private blockchain systems just being released, with all sorts of bells and whistles which are left up to the users to set. There's lots of stuff to be done. You know, IBM used to put out these red books, which are like cookbooks on what's the right way of using the system, under what conditions, what features should be used, what are the right values to set for these various knobs and so on. That's all to be done. Okay?
So I see two more questions, one on the left, and then we'll do the one on the right, and then we'll take the break.
CC Yuan with S-Core. So thanks for the excellent talk about the IBM software platform. Since this is a hardship conference, I'm wondering, on your page 31, you have one page you quickly mentioned how the layers, architecture layers, IBM supported. In hardware related, you mentioned you have HSM, the security model, and also the encrypted storage. Other than that, can you elaborate a little bit more about how you modify the hardware to
well, right now, the
performance challenges? Thank you.
Yeah, I mean, at this point, there isn't a whole lot of stuff that's being specifically leveraged in the hardware by the private blockchain systems. On the other hand, if you look at the open blockchain ones, because they have that proof of work where they are trying to solve this math problem as fast as possible, to be the first guy to do it so that they can get a few biscuits, bitcoins. There's like reward for having won that game, which is where all this ASICs and all that TSMC and other people have developed. By the way, I was asked to speak to AMAT people, Applied Materials, as well as KLA-10 core people, because they're all dreaming that maybe they can also make more money by doing something special purpose. But I'm unfortunately not happy with this whole notion of open blockchain for various reasons, as I mentioned. So in the private blockchain space, if you are encrypting the data, or like in a regular database system, you are doing some computation that is expensive, where things like FPGAs and GPUs are being leveraged, you could do that here. But at this point, at the layer that is the blockchain platform, that itself is in a very simple way doing things. So it doesn't have the sophistication of a SQL kind of language. That was my point towards the end. And as a result, the manipulation that's being done of the data is being done in a very simple-minded way, at least from what is visible to the blockchain platform, because the APIs are so simple-minded. It doesn't have fancy aggregation, that kind of operators. And so in the IBM blockchain platform, the leveraging of the hardware is happening for doing encryption and such efficiently, and also to provide the secure execution environment where there are hardware features with that secure container and such notions that come into play. But beyond that, I'm not aware of any interesting leveraging of some very unique kind of hardware features.
So you implied also Ethereum is a transfer from POW to POS now. And your IBM actually is not planning to do anything on hardware.
Did you catch that? I didn't catch the pure something to pure something.
From POW to POS.
POW to POS.
Oh.
Proof of work.
Yeah. So, like I said, in our system, we used to use PBFT. I shouldn't say our system. This is actually an open source system. In Hyperledger Fabric, in 0.5 and 0.6 release, the consensus protocol being used was PBFT, which is the practical Byzantine fault-tolerant algorithm that Barbara Liskov and company developed, which still had the property that it was deterministic. Only one guy got to add a new block, okay? It wasn't the one where, like in proof of work, where multiple people could add. But even that has been given up in version 1, where it's Kafka that's being used, where all that happens is that these clients publish on a topic, where the topic is the channel, all the transactions that they simulated in that channel, and then there is one listener, which is this ordering service, which grabs all those transactions, puts them into a block, and now it publishes the block using that same channel ID as a topic. So there isn't this proof of work, proof of stake kind of thing. But the architecture is such that if you want, you can plug in a different consensus protocol. But the base platform itself now comes out only with Kafka as the ordering service. So in that sense, at least in the fabric, there isn't any proof of work or proof of state or proof of asset or whatever. So,
Thank you.
okay.
And then our last question, please.
Yeah, hi, Charlie Demergent from Semi-Accurate.
I can't quite hear you.
Sorry, Charlie Demergent.
Maybe you should push it up a bit.
Yeah.
Yeah.
Yeah, technology. Charlie Demergent from Semi-Accurate. A friend of mine, much smarter than I, once described the value of Bitcoin as being one hash collision away from zero. Now that we have commercial implementations with fairly large assets being guarded or tracked by this, what if anything, do the commercial implementations do to react to, not necessarily guard against, this that kind of eventuality?
Well, I don't know exactly how to interpret this question because, first of all, I don't believe in any of that. So I'm concentrating only on the private blockchain. So what do you mean by guarding against it? And who are these private somebody you said?
Well, in any commercial implementation is doing something to protect something of value, or at least track something of value. If there is a fundamental attack or a fundamental problem with the underlying technology, is there a way for these commercial systems?
Well, I mean, that's what one of the first points I made, right? Which is you lose the private key, you are screwed. There is no recourse to anything. What is billed as the positive thing about this whole thing is a major negative thing, which is all this anonymity, blah, 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 that these guys will rattle on. When I go to some of these conferences, I feel as if I'm in a different universe, you know. They all will mumble decentralized, blah, 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 and, you know, providing for safe way of doing things. All that is predicated upon you don't lose your thing, and that the code is all, you know, error-free, this, that, and we know about all sorts of attacks and things that have happened. And even this whole complete decentralization is a lot of BS because a lot of the money that's being held is not being held by individual people in their wallets. There are now these so-called exchanges. Big share of the stuff is now in these exchanges. Why are they not like banks? If you're claiming that banks are bad and this and that, and I'm going to completely go to a decentralized world where all of us act like there's nothing central and we are all going to work with each other without even knowing the identity. Now, if these exchanges die, again, no protection. So it's for such reasons also that government bodies are all wrestling with all this. As I said, you know, CFTC and all these guys are now declaring some of these things as, hey, you can't fly under the radar. You are now going to be subject to tracking and this and that. So the only exception they've made is that, at least in the case of the SEC, they've said Bitcoin and Ethereum have a lot less of any single organization controlling them, and hence they don't want to necessarily think of that as a security. But you are still messed up if, you know, as it has happened, people have found ways to take money away from somebody and things like that because there were bugs in the code or features in the systems that allowed them to do these things. So you can't have the cake and eat it too. If you claim you don't want any of these pre-existing governmental entities to be part of the picture, and hence you do stuff, and then again, we are all greedy people, I guess. Somebody or the other figures out how to mess up the system and make money. Now, if you are going to say, hey, give me back some of that governmental control or ways of finding recourse, yeah. I personally don't have too much sympathy for all of these people because they relied on stuff where they bought a bill of goods and, sorry, face the music. Thank you.
Okay, with that, I think it's my duty to, we still have 2/3 of our coffee break left. It'll be on the right side here, to invite you to come back at 45 after the hour for the second part of the tutorial. And then my last task, if you would join me in thanking Mohan for this great talk.
Thank you.
So welcome back from the coffee break. My name again is Geoff Burr from IBM Research. I'll be the session chair for the rest of this first tutorial. And have the great honor of having Jana Novikova here as our second speaker. She is the Director of Product Management at Ripple, which she first joined in 2014. Jana is responsible for XRapid, RippleNet's liquidity solution that uses the digital asset XRP. Prior to Ripple, Jana worked as a software engineer at JPMorgan Chase, developing their credit card infrastructure and applications. So please join me in welcoming Jana.
Thank you. So good morning, everyone. Thank you all for coming. It's a pleasure being here today, and I hope you enjoy this talk. So as Geoff mentioned, my name is Jana Novikova, and I'm Director of Product Management at Ripple, the global leader in distributed financial technology. I started at Ripple 4 years ago. First, I was a product manager for XRP Ledger, and that's something we'll focus on in this talk. After XRP Ledger, I worked on Interledger Protocol, and Interledger Protocol is distributed ledger technology developed by Ripple to connect different ledgers together. Right now, Interledger Protocol powers our enterprise products, such as Xcurrent, Xvia, and XRapid. And now I work on XRapid product. An XRapid product is a RippleNet liquidity solution that allows our customers to source liquidity through XRP, Ripple digital asset. So what is Ripple? At Ripple, we work on what we call Internet of Value, basically enabling the world to move information, to move money the same way information moves today. So when you think about how we communicate, in our age, we can send a message to everyone in the world almost instantly and free. So why do global payments take days to settle, cost an arm and a leg, and are reliable? So what Internet did for communication, Ripple is doing for payments. At Ripple, we do believe that global payments should be real-time, on demand, and at a fraction of the cost what they are today. And that's our grand vision. However, our insertion point is where we see the most opportunity and the most friction right now, and that's cross-border payments. So we're making cross-border payments more efficient by selling blockchain-based settlement solution to financial institutions, and it's a two-part solution. First, it's software, and it's also digital asset, XRP. So at Ripple, we are building RippleNet, a modern global payment network infrastructure that allows financial institutions to meet demands of their customers. And those demands are constantly changing. If you think about what corporates wanted from payments in the 1970s, it's very different from what they want today. So we sell 3 products to the financial institutions. Xcurrent, that allows them to process real-time payments. XRapid, that's the product that I work on, that allows them to source liquidity on demand. And Xvia, that provides a standard interface for our customers to send money globally. So let's dive into these products a little deeper before we go to XRP Ledger. So Xvia provides one standard API, one standard connectivity to the RippleNet. So network is only valuable as its users. Right now, if you look at the banks, payment providers, corporates, all these entities have to manage, first of all, have to implement and then manage thousands of bespoke integrations into multiple networks in order to achieve a truly global coverage around the world. So Xvia provides them with this one modern API that allows them to get this global coverage with just one standard connection. And not only has this one standard connection, it also allows them to send real-time, traceable, and settlement-efficient payments. So this is Xvia. Now, a network not only needs the senders, it also needs somebody who's going to process those payments. And that's where Xcurrent comes in. So Xcurrent is a software component that our customers use at the core of their processing engines. Xcurrent, first time it ever happening that allows our customers to send real-time payments with end-to-end traceability. So the way Xcurrent works is that it's based on Interledger protocol, distributed ledger technology. And the way it's designed is that payment either completes entirely or not at all. And what it does, it eliminates the risk of delays and failures at any point of the chain. So another component that Xcurrent offers to our customers and the RippleNet offers to our customers is the rulebook. The rulebook to govern the network, the RippleNet network. So 6 largest banks in the world came together to develop those rules to govern the network. And RippleNet is the first blockchain network that actually has a rulebook. So now, as we have senders and processors, where does XRP and XRapid comes in? Well, not all our network members and not all our network participants can actually have access to cheap liquidity in order to process those global payments, especially in the emerging corridors. So using XRP and XRapid, those participants of our network who don't have access to cheap liquidity can source this liquidity through XRP, thus eliminating expensive intermediaries in FX transaction and reducing the transaction cost. So XRapid has 2 value propositions. First of all, it allows our customers to source liquidity on demand through digital assets. Because digital assets settle real time, XRapid allows our customers to do it on demand at the time of payment. The second value proposition is that it eliminates the need for pre-funded Nostro accounts. So XRapid allows our customers not to necessarily keep fiat currencies in different destination markets where they want to send payment. Instead, they can use XRapid and XRP, the digital asset, to source the liquidity on demand. So how does it work right now? Well, XRapid connects to liquidity pools around the world to source the liquidity. And those liquidity pools provide liquidity against XRP ledger digital asset. So here in the picture, in the diagram, you can see 2 exchanges. So imagine we have a customer who wants to send dollars into Mexico, and they want the receiver to receive Mexican pesos. Well, the way it would work right now, the sender would have open accounts on both exchanges in the US and exchange in Mexico, and you see those 2 on a picture there. So this one originates in exchange. This is the destination exchange. The sender only needs to pre-fund dollars at the originating exchange. Say this is the exchange in the US. And if exchange allows real-time funding, they don't even need to pre-fund dollars there. They can just keep dollars in their bank account, and the exchange will issue them credit at the time of payment. So they pre-fund the dollars at the exchange, and then they use XRapid to initiate the payment. And the way it works, XRapid connects to the dollar exchange. It exchanges dollars for XRP. Then it takes, or trades dollars for XRP. Then it takes XRP and withdraws them to exchange in Mexico. So here. The withdrawal from exchange in the United States to exchange in Mexico would only take a few seconds, because the transaction will settle through XRP ledger, and transactions on XRP ledger settle within 5 seconds. So once XRP gets to exchange in Mexico, there it's sold for Mexican peso, and Mexican peso are withdrawn to a beneficiary in Mexico. So this entire payment flow only takes a few minutes. And if you use traditional rail, for example, banks or any other traditional financial institutions, this flow would take at least a day, if not 2 days. So Xrapid allows our customers to source this liquidity at the time of payment and process payments more efficiently and faster. So you might ask, why XRP? Why not use other digital assets for these type of transactions? Why not use Bitcoin? Well, let's look at different characteristics or different focus areas that digital asset needs to have in order to allow for efficient settlement. So the first characteristic is transaction speed. So right now, it takes up to 45 minutes to confirm a Bitcoin transaction. And that's because of the Bitcoin ledger, Bitcoin blockchain scalability issues. So XRP transaction takes only 4 seconds to settle. And we'll go into detail why it takes so much faster than Bitcoin as we start looking at XRP ledger and consensus protocol. So the next category is transaction cost. So right now, it costs up to 85 cents for Bitcoin transaction. XRP transaction on XRP ledger is still less than a penny. And the third characteristic is throughput. So right now, Bitcoin blockchain can only process 32 transactions per second. XRP ledger can do 1,500 transactions per second. So these are 3 really important characteristics that the digital asset has to possess and has to perform really well on in order to enable efficient settlement for global payment system. Let's think about other characteristics, though. Another category to consider is flexibility. So for entire world to use Bitcoin as a settlement mechanism, everybody has to adopt Bitcoin and transact at Bitcoin so they can move money efficiently around the world. Well, this is not possible. With XRP, you don't need to adopt XRP. XRP can only be used as a bridge asset to tighten the spreads among different fiat currencies. And the world can still continue using its fiat currencies. The other category or the other characteristic that's worth looking at is energy efficiency. So we all know that Bitcoin mining takes massive amounts of energy. So right now, to confirm Bitcoin transaction, it takes about 162 kilowatt of energy, which is enough energy to power few households for the entire day. XRP ledger, however, XRP ledger transactions are confirmed by a distributed network of validators. In order to run a validator, it takes as much energy as running an email server, so pretty much nothing. And then the last piece that it's worth looking at is stability. So we all know all these debates in Bitcoin around hard fork and disagreements among the core group on future of the protocol. So this is a lot of instability for the global asset that could be used for settlement. XRP and XRP ledger has been maintained by the same group of developers for the past several years. This is high-class, world-class C++ developers, and there hasn't been any governance issues so far. Since the inception, XRP and XRP ledger closed 40 million ledgers today. So these are all characteristics to look at when looking at what would be the best digital asset for settlement. So at Ripple right now, we have 270 team members. 2/3 of them are engineers, and we have members of our team with vast array of experiences in different industries. We're headquartered in San Francisco, in Financial District. We also have offices in London, New York, Mumbai, Sydney. This is our customers. So we've been in business since 2012, and we have a vast array of customers. We work with major financial institutions, payment providers, corporates, in order to move money globally. So let's move to XRP Ledger. So what is XRP Ledger? Well, XRP Ledger is a decentralized cryptographic ledger for issuing, holding, transferring, and trading arbitrary assets, including its native currency, XRP, a digital asset designed to bridge the many currencies in the use worldwide. So this is a very, very heavy definition, and I'll pack it in a bit. But before I unpack it, Let's look at the history. So original idea for XRP ledger was proposed in 2004 by Ryan Fugger, and he called it Ripple Pay. It's a basically decentralized peer-to-peer P2P credit system. However, the development of the system didn't start until 2011, and that system right now became XRP ledger. So basically in 2011, Jet McCaleb and David Schwartz, Jet McCaleb hired David Schwartz and Arthur Breeder to find another way to solve double spend problem without using central authority. And what they came up with was distributed consensus protocol or distributed agreement protocol, which is used to confirm double spend problem, which is used to solve double spend problem. So basically, this protocol and this agreement is like a room full of people agreeing on something. So as long as the protocol agrees on what transactions to process, and as long as we know what transactions they agreed on, this solves the double spend problem. What they also did, in opposition to Bitcoin, or as opposite to Bitcoin, they replaced blocks with ledgers, and they also allowed arbitrary assets. And I'll go over arbitrary assets in my later slides. So once XRP ledger was created, they also created 100 billion XRP. And 100 billion XRP was gifted by creators of XRP ledger, which I mentioned on the slide. They are gifted to a private US company named OpenCoin. And OpenCoin is what became Ripple. So what are ledgers? So ledgers are the current state of the universe. It's like the contents of the database. However, instead of having transactions, unspent transaction output, which is sort of collected over time, ledger has everything in it. And ledgers form a secure hash in XRP ledger network. Secure hash chain, I'm sorry. So transaction sets advance the ledger. And what it means that the prior ledgers can be forgotten. So if you ever ran Bitcoin node, or if you try to spin up Bitcoin node, you would know that it takes really, really long time for you to sync to the network. And because in Bitcoin, you have to synchronize all transactions that ever happened on a blockchain in order to come to the current state. Well, in XRP ledger, you don't have to do that. In XRP ledger, prior transactions can be forgotten, or you can keep them if you want to keep the full history. So what does ledger contain? First of all, ledger contains transactions themselves, and it also contains the metadata. And metadata is description of what a transaction did. So for example, if I paid you $10, the metadata will describe that I paid you $10, and presumably the transaction succeeded and I paid you $10. And this really works for simple transactions. And it's just enough to know that transaction succeeded. So for example, if I write a check to pay someone, it's enough for everyone to know that the check went through. However, what if we have more complicated transactions? What if I pay 10 euros to somebody at the current rate, and I was willing to pay up to $12 in order for this payment to succeed? Well, in this case, just to know that transaction succeeded is not good enough, because I don't know how much money I ended up spending. I don't know who took my dollars. I don't know who paid the euros and what the current rate was. So a more sophisticated system that tracks a more sophisticated transactions can support these type of scenarios. So what are advantages of the ledgers as opposed to blocks? So ledgers ensure reliable agreement on a network state. With ledgers, you can also control the network growth. So if you don't want to keep the entire transaction history, you can discard it, and your server only needs the recent ledgers. And you can also spin up your nodes faster. So because your node doesn't have to synchronize the entire history that happened over the network, you can spin up your server way faster than the ones that do require to do that. So ledgers eventually come to consistency through consensus. And consensus is a distributed agreement algorithm similar to practical Byzantine fault tolerance algorithm. So what's interesting about consensus that with XRP Ledger is that it doesn't require 100% agreement on the participants. So prior algorithms required you to agree on who's going to provide who would be the participants in a network. XRP Ledger requires substantial agreement, not 100% agreement on those participants. So what it means is that you can add and remove people without agreeing who is in and who is out. And that's XRP Ledger method of solving double spend problem. So transactions are applied as unit and groups. It's like a room full of people trying to agree. And one reason why it's robust is because an honest server only cares about the agreement. So if you imagine if we all try to agree what to have for lunch, well, we all have different preferences. Some of you might be vegetarian, some of you might not like gluten, some of you might be on a low-carb diet. So it will be very hard to agree because all of us have different interests. But imagine if we all cared about is agreeing. So imagine if all everybody wanted to do is to agree on that we want to go to get a place to eat, to pick a place to eat. So if somebody proposed, oh, let's go to a movie theater, well, that's not a place to eat, no. However, somebody said, let's go to a Burger King, yes, that's a place to eat. Let's do it. So it's a much simpler problem when different participants are aligned or they have aligned interests, but not unique interests. If they all agree on just getting the valid transaction in, that's what happens during consensus on XRP Ledger, the agreement is much simpler. So what's interesting about the consensus is that you can also solve double spend problem through transaction ordering. Why? Because transaction is valid or not, because if transaction is valid or not is very deterministic. So if you want to spend money, you have to have it. Executing transaction, if it transfers money which you have, it succeeds. If it transfers money you don't have, it does not succeed. It is very deterministic, and we can all agree on it. And transactions can either conflict or they don't. If I try to send money to two different people, we all agree that second transaction will fail. But what's the second transaction? So I might see one transaction first and the other transaction next. You might see the other way around. So as long as we order transactions in specific order, this is sufficient to solve the double spend problem. And that's exactly what validators do on XRP Ledger. They propose a set of transactions, and they avalanche to consensus. So if you think of an avalanche, it's like a snowball on the top of the roof. Once it starts tipping to one side, everybody starts pushing it towards in that direction, and the consensus happens. The agreement happens very quickly, and validators sign the ledger. So it turns out that this type of consensus is very robust. And for the set of reasons that there is a much simpler problem than officially it was thought. One reason is that all honest participants will vote to include transaction if there is no reason not to include it. So if I say I want to transfer $10 to Bob, I have $10, Bob is a valid account on a network, and there is no reason why the system should not record this transaction. If everything looks fine, all the network participants will say, yes, this is a valid transaction, this should go in. And if transaction has any reasons not to be included, maybe it's double spend problem or something else, it's fine, it's not going to be included. And if it's still valid, then it will be included in the next round. So the consensus algorithm is biased to exclude transactions to reduce the overlap required. So what it means is that if we can't agree on the transactions, if there is a lot of them and there is a lot of disagreement, then we can reduce the amount of disagreement by eliminating transactions and by not accepting more transactions into consensus. So that way, eventually, disagreement continuously drops, and we'll end up at a set of transactions that we agree on, we move forward, and then we'll start addressing the ones that were dropped. So what are the advantages of consensus? Well, it has no rotating dictators. So if you think about Bitcoin and Bitcoin miners, a miner actually chooses which transactions to include on a block. With consensus, there is no rotating dictators, and there is no forced stakeholders. What it means that if that consensus can be used for financial transactions, So if you think about Bitcoin, if a person controlled all transactions that go through the network, like a miner could, then this person could derive some kind of benefit by doing controlling all the transactions and blocking some of the transactions. So for example, they could take the juiciest offers or trade orders on the network. They could prevent certain people from transferring the funds. And that's something that's not possible through consensus because there is no dictators on a protocol. The other benefit of the consensus is that users can choose which validators they'll trust. Consensus is fast. It's only 3 to 5 seconds to confirm transactions. The reason why it's 3 to 5 seconds, each consensus round, where validators propose transactions and agree on transactions, only take 5 seconds. And the last but not least, obviously, is the past cannot be rewritten. And that's the advantages of the consensus. So XRP Ledger, what are the key features? Well, it's open source ISC license technology. It's a public ledger, public transactions, public history, equal access, no central authority, permissionless. It's being worked on by a group of developers. They are world-class C++ developers. The XRP Ledger is written in C++, and those developers have been writing modern C++ software for the past several years. It has fast, reliable confirmation, and it uses elliptic curve technology, as well as have native multi-signature support. So if we look at how Ledger looks, so first of all, Ledger has a sequence number or ledger number, and we call it ledger index. And ledgers are numbered incrementally. So right now, network has 40 million ledgers, and you can extract every single ledger that ever closed on the network. So you can get any of them, any of the 40 millions. So besides ledger number, ledger contains information about accounts. And account can have certain account settings, trust lines, balances, and so on. Any changes to the ledger can only be done through a transaction. Examples of transactions could be a payment, could be a change to account settings or trust line. It could also be an offer to trade. So each transaction authorizes changes to the ledger and is cryptographically signed by account owner. Transactions are the only way to authorize changes to the ledger. Once the ledger is validated, it has a timestamp, and it has a state that it's been validated. Before ledger is validated, it has a different state, such as proposed or current. So now that we know how the ledger works, or how XRP Ledger works, you might start asking yourself, so how do you move assets on a payment system that is not connected to any sort of financial institution? You might imagine you have a payment system like Visa or eBay, and that's the network that has infrastructure that moves real money, and you might wonder, how would you move money on a system that's not directly connected to the infrastructure that moves real money? And the answer to that is through virtualizing arbitrary assets. So an asset has an issuer and a currency. So let's say we have dollars issued by Wells Fargo. And because an asset can be issued by anyone, in XRP Ledger, you can only hold assets that you choose to hold. So for example, if I have a cousin who issued dollars on a network, and I don't want to hold their dollars because it's not very reliable, I would rather hold dollars from Wells Fargo. I can choose to only hold dollars from Wells Fargo and not my cousin. In addition to that, assets have a counterparty. And what it means is that there is a legal obligation. So if XRP ledger says that Wells Fargo owes me $10, well, the ledger is reporting that XRP ledger network knows that it's true. So, however, in addition to that, there is a separate legal obligation for Wells Fargo to owe me those $10. So presumably, if something terrible happened to XRP ledger, that legal obligation would still exist. So there are a bunch of accounts on the network, and those are identities on the network. They all trust each other. They form a directed graph. Oh. There we go. They'll trust each other. They form a directed graph. And what it shows is that Alice is willing to allow Carol to owe her some money, and Alice is also willing to allow Edward to owe her some money. And of course, in the real world, it would be financial institutions, but it could also be people. And so in the physical world, you can have money by sending money to somebody. So an Alice can send $100 to Bob, while Bob takes his $100 and pushes electronic asset to Alice. And this electronic asset can be in any system we want. It doesn't matter. What's important is that Bob owes Alice $100, and it's a real fact. And the system recording this fact. The fact is a fact, and the fact is that Alice sent $100 to Bob. So Bob owes Alice $100. Alice has a digital asset that tells her that Bob owes me $100. Now Alice can transfer this asset in any system we want, as long as Bob is willing to honor it. So if Charlie also trusts Bob, and Alice wants to send $100 to Charlie in any system that Bob is willing to honor, it doesn't matter who's running or who's on it, as long as Bob is willing to honor the system, Charlie can redeem those $100 with Bob. However, if you look at this system, it's not very usable because, as you can imagine, there are so many people we all can trust, and there are so many people they can form this directed graph where we'll get this kind of spaghetti network with large number of participants, which won't be very usable. So what's the solution to that? The solution is the hub, to have a hub. And a hub could be a bank. It could be another financial institution. But if there are a lot of people that are willing to consider Wells Fargo owing them $1 to be worth $1, then you'll consider it to be worth $1 just because you know everyone else around you considers it worth $1. However, the problem with that is that you wind up with a bunch of islands of trust. You end up with Wells Fargo issuing dollars, you end up with some other financial institution issuing euros, you end up with somebody issuing Bitcoin, company issuing Mexican pesos, and so on. So now you have all these different currencies. So how do you build a global payment system out of arbitrary asset system? Well, you do it with offers. So these round things in the middle with double arrows around them, inside of them, are actually connectors. They have asset or account on both systems, on both sides of the system, and they're willing to trade one asset for another. So if you owe dollars at Wells Fargo and you're willing to take euros to transfer somebody's dollars, somebody could make a payment by giving you dollars and by giving you euros, and you can transfer dollars to their account. So you can put together an international payment from two domestic payments. So if I want to pay someone in China, and I find somebody in China who wants to take my dollars and who wants to supply Chinese currency to my beneficiary in China, then that would work. Those two domestic payments can become one international payment from my point of view. So arbitrary assets, how do they work? Well, money doesn't really move. You notice we didn't move actual real money. What we changed, we changed who owned the money, and that's just as good as moving the real money. So Alice wants to pay Bob $10. What Alice wants to do, she actually wants Bob to have a title to $10. So she considers to pay them. So you don't have to move any money. You just have to swap ownership of the assets. So sender loses the custody of the asset, recipient gains the custody of the asset. And payments in XRP Ledger, payments ripple through the intermediary who facilitate the payment by losing custody of the asset and gaining custody of the asset. And of course, they get benefit from doing so in the form of fees. So this is how XRP Ledger works or structured on a high level. So now that we know how it works and what's inside the ledger, let's look at consensus. So again, to refresh your memory, consensus is a distributed agreement protocol that's used by XRP Ledger network to confirm transactions. So if we look at XRP Ledger network as a whole, it's pretty much a network that consists of a bunch of nodes, or a bunch of distributed servers, we call them nodes, that accept and process transactions. So client applications sign transactions, and they send those transactions to nodes, which relay these transactions throughout the network for processing. So examples of client applications could be web wallets, could be mobile wallets, could be financial institutions, gateways, could be electronic trading platforms. The nodes that receive and process transactions may either be tracking nodes or validating nodes. So here in the picture, you see blue validating nodes and white tracking nodes. Only validating nodes contribute to advancing the ledger sequence. So only validating nodes has the authority to increment the sequence and issue the new ledger on the network. So when tracking nodes accept the transactions submitted by client applications, each tracking node uses the last validator ledger as a starting point. That's always a starting point for them, and they accept transactions from client applications as candidate transactions. So those are candidates to be included. So at the start of consensus process, validators propose transaction sets. So all the blue nodes propose transaction sets. Because if you look at different nodes in the network, they all have different sets. So consensus starts by validators propose transaction sets. And rounds and rounds of proposals determine which transactions apply to the ledger and which must wait for the later round. So once that happens, nodes agree on transaction set. So nodes apply agreed upon transaction sets in this picture shown in green to the last validated ledger. However, transactions which are in this case in red will not be included in the set, and potentially will be agreed upon in the next round. And that's related to what I explained, how if there is too much disagreement, certain transactions will be excluded from the consensus round in order to reduce the disagreement and potentially agree on those in the next consensus round. So each network node calculates a ledger validation. So basically, each tracking node applies agreed upon transactions to the last validated ledger. And then validating nodes send their results to the entire network. So if you look at this picture, we had a previous validated ledger. We have which shows in black. We had a new transaction set that was agreed by all participants in the network, or majority. Then this transaction set, new transaction set, was added to the ledger, to the new ledger. The sequence was incremented, and that's the ledger that will be validated by the network. So ledger is considered validated when supermajority of peers calculate the same result. So all nodes compare their calculated ledger with their hashes received from chosen validators. And if it's not in agreement, then the nodes must recalculate recalculate the ledger, or they have to retrieve the ledger that was proposed by validators. So you might ask, who are those chosen validators? Well, chosen validators is a subset of network, which is taken collectively, is trusted to not collude in an attempt to defraud the node evaluating the proposals. So the definition of trust doesn't require that each individual chosen validator is trusted. Rather, the validators are chosen based on the expectation that they will not collude in a coordinated effort to falsify data related to the network. If the network fails to achieve supermajority agreement on validations, if there was too much disagreement, that implies that either there was a lot of transaction volume or there is a high network latency. So for consensus to produce consistent proposals. And that's why what you see, if there is a lot of network volume, the consensus takes longer because it has to go through many more rounds of proposals before the specific transaction set is agreed by validators. So in that case, consensus process just repeats again. And it's possible that it would take more than 5 seconds. Again, that's the case when there is a lot of network volume or there is a lot of latency. So network recognizes the new validated ledger version, and every node gets it. Every node updated the validated ledger, and the whole process starts again. So the consensus begins again with a new set of transactions, but now this new validated ledger becomes the first ledger on the network, the one that will be applied transaction to. So and that's how consensus works. And it's time for questions. Thank you.
So those who have questions for Jana after her talk, I think I see a first question over here.
Thanks.
Name and affiliation, and then ask your question. Thanks.
Nathan Brookwood, Insight 64. When you talk about the consensus validation taking place in 3 to 5 seconds, because users are making that decision, who are the users? It can't be humans, I assume, so it must be some sort of proxies. And how are they validated to be able to vote?
So the users on the network are validators. It's the servers. It's their RippleD node application or server that runs a validator. And there is a certain algorithm that allows validators to achieve the consensus.
So as a follow-up, how does a node joining this network get validated as being a legitimate node? Because I could see all sorts of opportunities here for fraud.
Yeah, so when you join XRP Ledger network and you become a validator, users who use the network, they choose which validators they want to trust. So there could be hundreds and hundreds of validators. However, you might want to trust only a specific set of validators, maybe which is operated by banks. Or you might want to trust validators that are included in the United States and not in, say, North Korea. So it's up to the user which validators they want to trust. And that setting is determined in XRP, like when you run your node of XRP Ledger, there is a setting there where you can choose which list of validators you want to trust. So it's up to the users of the network to choose which they want to trust. And of course, there could be malicious validators, but if nobody trusts them, that they cannot do any harm to the network.
How would people know they were malicious?
So as I mentioned, as long as the majority is not malicious, as long as you choose a group of validators that you know is not going to collude to defraud you. So it's not necessarily a single validator in the group of validators needs to be trusted. It's just the group taken collectively together should be trustworthy. And as long as that condition holds, then you should be good to have a good network.
I think you're being naive, but I'll give up the mic.
Another question on the left.
I'm Gerald. I have rather a legal question. So let's assume I have an account with XRP and I have an asset and I want to transfer that asset to a different. I want to transfer the asset to a different account. So I have one account and I want to transfer the asset to a different account. And let's assume the validators refuse to transfer the asset for legal reasons. For example, let's assume I'm a Chinese dissident and the Chinese validators refuse to do the transaction. So what legal entity is liable that I can sue to enforce the transfer of the assets? And yeah, the next question would be, what's the compensation for the validators to do the transaction and to approve of it?
So the first question is, who is the legal entity that will be liable if you trust a validator that maliciously took your...
No, it's much simpler. Let's assume I have an account with XRP and I cannot transfer the asset out because the validators refuse to transfer the asset.
Why would validators to refuse?
Country restrictions. When our validators, for example, situated in China or in the US or somewhere, the Chinese or the US government says, you're not going to do this transaction.
So just pick a different set of validators that will transfer your asset.
No, but there has to be a super consensus, no?
What's that?
There has to be a majority consensus.
Right.
So if the majority consensus doesn't happen, you will never transfer your asset.
Right, that's exactly right. But then you are assuming that the majority of validators does not want to transfer your asset.
That's why I'm asking, who is the legal entity I can sue?
There is no legal entity in XRP Ledger network. There is no central authority. It's a decentralized network.
But you have to understand that's a problem, because there's no legal recourse.
Well, there is no legal recourse in any decentralized network. There is no legal recourse in Bitcoin or Ethereum.
That might be correct, but if you want to grow and have a real business, they need that. But to the second question, what's the compensation for the validator?
So there is no compensation for the validators. Anyone who wants to run a validator is somebody who's interested in the stake of the network. So by running a validator, you can vote on network protocol changes. So if there are certain features that are being released on a protocol, and as a validator, you can vote for this feature to be included or not included in a protocol. As well as by running a validator, you participate in the network. So if your business depends on a network, say you're an exchange or you're a wallet or you're a payment provider that uses XRP for liquidity, you have a stake to run the validator.
Okay, question here. Michael Shea from UC Berkeley Extension. The question here is, we all know the currency has been backed up by the government. Your operation is to guarantee the transaction will go through. Is that true? Is my understanding not correct?
So you mentioned the currency is backed by a government?
Yeah, for example, like US dollars, that's backed up by US government, although the dollar bill prints that in God we trust. So whichever God that the US trusts, that's the guarantor ultimately. So for your operations operating on some kind of a cryptocurrency, who's the ultimate guarantor?
Are you asking who's ultimate guarantor to XRP or whose ultimate guarantor to the assets has been issued on XRP Ledger?
All of them.
All of them?
Explain.
So there is no guarantor to XRP. XRP is a decentralized, XRP Ledger is a decentralized network, and XRP is a digital asset within the network. So there is no central authority that guarantees XRP. The XRP transactions are guaranteed by algorithm that's running behind XRP Ledger, by algorithm and cryptography. So if you're talking about the assets that can be issued on XRP Ledger, those are guaranteed by the issuance bodies. So if, for example, you decide to start a gateway on XRP Ledger, you can take somebody's dollars and you can issue them on a network. Then those who take those dollars, those who have those dollars on a network, you'll be guaranteeing that you still have those dollars to back them up in physical world versus the digital world.
So the backup currency will still be the default or legacy currency. Is that what you're trying to?
No, what I'm trying to say is that on XRP Ledger, you can do two different things. You can use XRP as an asset, which is decentralized asset, same as Bitcoin or Ethereum. There is no backing for there is no central authority that backs XRP. Same way as there is no central authority that backs Bitcoin. On the other hand, you can also issue fiat currencies. So XRP Ledger is not only having XRP. On XRP Ledger, there are functionality where you can issue dollars or Bitcoins or euros. And as long as people trust you to issue those currencies, that means they trust either your legitimate financial institution or your legitimate payment provider who wants to issue a currency on XRP Ledger, then you are the one who's guaranteeing that currencies. So you can do two different things on XRP Ledger in terms of which assets you want to use. You can use the native digital asset, or you can issue other assets. Same as you can do ICOs on Ethereum. It's very similar you can do on XRP Ledger.
Okay, so it's particularly speaking, it's in Ethereum we trust. It's the same thing like US dollars. Okay, so in X we trust. X could be anything.
So XRP is backed by the cryptographic protocol that's running on XRP Ledger.
We trust.
Yes, so you should trust in protocol, and in people who develop the protocol, and all the network that runs the protocol.
Thank you. I finally understand. That's in protocol we trust.
Yes.
Thank you. Thank you.
So I know we have one more question, and I also know that since you are all from the chip architecture area, you're all experts in organizing data flow. And what I need to do here is organize human flow, because the food vendor is going to be very cross if we all show up for lunch before 12:45. In fact, I think they've been provided with a picture of the session chair. So in order to set up my own transaction for lunch, what I've done is also brought up Mohan on stage. And so for those, I'm sure the next question is for Yana, but if you had a question for Mohan and you didn't get a chance to ask it, please come on up to the microphone and we'll ask questions until we can all go and eat lunch. So with that, ask the next question again, name and affiliation, and ask your question, please.
Yeah, Yana, thank you. It's a very interesting presentation. David White, Hardware. So my question relates to the cross-border payments, and the scenario you illustrated broke down to basically a set of local payments. Mm-hmm. How is that different from TransferWise?
So what we do different with Ripple is that using our technology, you don't have to pre-fund. So for example, right now, if you use TransferWise, the reason why TransferWise can efficiently or process your payment within probably minutes is because they have dollars pre-funded in Mexico, or not dollars, say Mexican peso pre-funded in Mexico, or they have Thai baht pre-funded in Thailand. So when you want to send from dollars into Mexico, they just pay out from their Mexican bank account or their partner Mexican bank account. So with Ripple and XRP and XRapid, what you can do, you don't have to pre-fund those Mexican pesos in that bank account, or you don't have to pre-fund Thai baht in Thailand. So not only it eliminates the need for these pre-funded Nostro accounts, it removes these working capital requirements, as well as it removes your risk to FX currency fluctuations. And you can, instead of having those pre-funded accounts, you can source liquidity through XRP, through digital asset, through digital liquidity pools that exist around the world. And so this is kind of what our software does differently than TransferWise. However, one thing to point out is that our software is not a consumer-based application. So somebody like TransferWise would use actually Ripple to process payments more efficiently. To you user, it would probably be, you wouldn't even know, do they use Ripple, do they use pre-funded Nostro accounts, because to you experience will be the same. However, TransferWise will be the one using our software, using our network in order to process payment more efficiently and reduce their cost of doing business in cross-border payments.
I got it. Thank you.
Question on the left.
Oh, thank you. May I ask a question to Dr. Mohan?
Sure. Thank you.
I didn't get a chance to ask in the last session.
Sure.
Forgive my ignorance. The question I had was, As I understood, blockchain represents a completely distributed system. That means everyone, whoever has a computer, can join and start a transaction using blockchain technology. Is that right?
Not in the private blockchain.
Okay, in the private blockchain, could we limit how many parties could participate in the transaction?
As I said, I assume you were there from the beginning of my presentation?
Yes.
Okay. So as I said, in a private blockchain, only people who have a reason to be there, meaning they are part of a business process.
On invitation only?
Sorry?
On invitation only? Being invited only?
Yeah. Meaning, think of the real world, where there is some business process. Yes. Ignore for the time being blockchain. There's a business process that involves people. They, meaning the organizations that are part of that business process, they choose to form a private blockchain network. And then it is those people who have come together for this purpose. It could be Apple and all its suppliers, Walmart and all its suppliers, or banks which want to work together. They form a network, and they get to decide, as part of that network, who gets to play in it. That's it. So just because you have a laptop and you have nothing else to do, you cannot willy-nilly just become a participant in these private blockchain networks. Unlike in the public blockchain, where people just say, I'll make some money by doing this mining and all sorts of random things like that, it's kind of meaningless is my point. So in the private blockchain, as a result, the current participants or whoever starts the network gets to decide who is in, who is not in. And the price of admission is also that you need to be able to, you need to reveal your identity and get a certificate and all that. So all this, madness with do I trust or not and all that, would you get into a car if you didn't know anything about the driver? Uber kind of situation. So, or Airbnb. So while it sounds good to talk about all this, I'll let anybody from anywhere without revealing a whole lot of stuff become a participant, and I'll over time build up their reputation, blah, blah, blah. Reputation without knowing identity is still a bit hokey.
I like your explanation. That finally made me understand. But the question here is, I have had this issue called the scalability. How many parties can we really afford to invite so that the throughput will not be punished or penalized?
Who won't be punished?
No, the throughput of the system.
So yeah, scalability is something, of course, that's currently a big focus. And so as part of that, these things are being addressed. And also the other thing to keep in mind is, I've been talking about the, let's say, the suppliers kind of situation. It could be Walmart and all the people who are supplying food or whatever items Walmart is selling. Not every Tom, Dick, and Harry who is a supplier will necessarily have the wherewithal to run a node and be an organization. Maybe some, farmer with a small plot of land. So such people, just like in the real world, might form, by grouping themselves, a cooperative, and the cooperative then is the representative for this group of people. And that might be the one that has a node and is an organization, and these individual farmers that are part of this cooperative will become users. So things like that have to be done. And this is no different from, in Germany, there are these itsy-bitsy banks, and they didn't have the wherewithal in the good old days to even run their own IT operation, forget the cloud and all that for the time being. So they formed a cooperative, and that cooperative entity became the service provider for them in terms of running their IT and things like that. So there are any number of these sorts of real-world things that one can look at and learn from and do things in a way where even the scalability kind of issues. And as I said during my presentation, just because there are, let's say, 1,000 people in a network, that doesn't mean they're all involved in every transaction. By the notion of this channel, there are subsets that are the ones that have business need to even access to certain set of transactions and such. And so that also provides another mechanism, and that's what was done in version 1 of the Hyperledger fabric, by introducing the concept of channel and even restricting from a visibility perspective which members of a given network get to see what's happening with respect to certain set of transactions and certain assets that are being managed in that fashion. So there are various ways to skin this cat of scalability, but fundamentally, not having to do any of this fancy validation, this, that, is already a big saving in terms of wasted effort and things like that that go on in the more traditional way of doing things, where, as I explained in gory detail, in Bitcoin and such, they go from day zero of the network and compute what the current balance is, which is kind of maddening. They don't keep a running current balance.
Thank you for explaining to me, so I finally understand a little bit better. But I mean, considering all these technology, I mean, I understand now this is a beautiful technology, but as a business owner, why on earth I want to use that one to allow either the bank or my mortgage owner or the government, IRS, for example, to have an easier time to go after my behind?
Wow. First of all, I'm going to assume that, unlike maybe some other people or whoever, with ulterior motives, we all want to do things in the legit way. Given that, then the question is, what are the ways in which, when things do go wrong, I can track things? By going wrong, I don't mean somebody stealing somebody's money or whatever. Legit things like E. coli disease or whatever, something that's spoiled that people didn't know, or a seat belt that doesn't work, brake that doesn't work. And we want to be able to do recalls and all that efficiently rather than mass recalls. For that, the systematic way of doing bookkeeping, that is the major value prop. That doesn't get discussed when you just talk about few people sending money around and all that. Yeah. When you are really dealing with real-world kinds of scenarios where this root cause analysis when something goes wrong requires knowing precisely what happened when and under what conditions. I didn't even mention the famous acronym of IoT. If you listen to my presentation with the same set of slides multiple times, guess what? I wouldn't necessarily be exactly repeating the same thing. So for that reason, if you're more interested in this topic, go watch some of the other videos, and you'll hear a lot more discussions about how IoTs and blockchains are being combined, how AI and blockchain, we even had a panel a few months ago. There are videos of all that. And even things like stable coin, which is an alternative to this business of converting from crypto to fiat currencies. IBM recently formed a partnership whereby there is a stable coin that's one for one, always kept in sync with the dollar. So essentially, you can think of it as digital fiat currency. Right. That is just easy to do business in, but it has none of this hairiness with things changing at the will of a few people or whatever, that comes into play with foreign exchange conversions and so on. It's aggravated when you have cryptocurrencies, and then there's all this speculative nonsense that's going on currently, which just is mind-bogglingly awful. Supposedly, some of these people are fixing the problems with fiat currencies, values going up and down like crazy, but they've, in the process, introduced yet another thing that's also being speculatively, traded around, and all sorts of chaos is emanating from that.
So, Mohan, can I insert myself here? So in this exercise, not in data flow, but in human flow, I'm told that the food vendor will be almost as upset with the session chair if no one shows up at 12:45. So I would propose the following. I would propose that we divide ourselves as an audience into two parts. Those who are ready for lunch, please get up quietly and go and get your lunch. It will be outside the front door. Those who would like to continue this discussion, have questions, just wait out a minute, and we'll continue this discussion with the microphones while some people go and get lunch.
I think most people are voting for lunch.
That's fine. Well, in that case, if you have
questions,
but
I still see that a couple of gentlemen standing
there. But let's, while everyone is here, please join me in thanking both speakers, Mohan and Jana.
Thank you.
And with that, since you've been waiting to ask your question, please, if you're ready with your next question. Thank you.
This is Zhao from Xilinx. And I'm just curious for one aspect. Even if I trust all these protocols and consensus mechanism, if something malicious get accidentally transferred, is there any way to stop it and minimize the damage?
Well, if you only have one malicious actor, they won't be able to disrupt the consensus protocol because the majority would disagree with them and their attempt to stop a transaction would not work.
Yeah, yes, I'm just saying even if the consensus it accidentally happened, let's say it's a fact, so it happened, how could, is there any way to stop it or minimize the damage?
I think his question is, algorithm has a bug in it, as a result of which some bad things happen. Is that right?
Yes.
Yeah.
So no, once the consensus goes through and your transaction got into the transaction got in the ledger and the ledger is validated, there is no recourse. You cannot just replay it or revert it back. That's how the protocol works.
In fact, along those lines, people have asked us at IBM with the blockchain as a service offering, look, it all sounds good. What if the smart contract itself had some bugs in it? This is no different from traditional database applications. A new version of the app gets rolled out. It goes and clobbers the database. You can't tell them, oh, go with bit tweezers and muck around with it to fix it up. So traditionally in the database world, we have had this notion of point-in-time recovery. So the way you do that, as you are about to install a new version of the app, you take a backup, and then you go forward, and then all hell breaks loose, unfortunately. You say, tough luck, roll back to that point that was established before this new version of the app got installed, and amnesia time with respect to what happened after that. So resubmit your transactions, whatever. Of course, this is all anathema to this whole blockchain notion that, oh, it's been cast in concrete, I can't go unwire that stuff. But customers are saying, this is not realistic enough. So don't tell me that I have to go through some other means, hoops, to somehow fix up this problem that came about. This is no different from, the ATM wrongly dished out tons of money. Banks wouldn't say, hey, or whatever, yeah, rockets and all that, once you fire, you may not be able to compensate it. But we have had to deal with this in the real world, and so just because it's blockchain, it has certain characteristics that turned on people. We cannot just say, hey, there's no other way to deal with this, and we have to think more practically.
Well, then, of course, if it's like huge bug that affected everyone, the network can agree to roll back and start from that point. Again, it has to be some kind of major event. If you just submit your own transactions because of your own fault, that's not gonna, you won't be able to just roll it back because you made a mistake. However, if there is a huge bug in the protocol and that's creating certain issues on an entire network, of course, network can agree to fix it, to put the fix in and then roll back potential and then start from that point.
Thank you.
However, it has to be agreed by the entire network.
Okay, so we would definitely like to entertain more questions, but the folks in back also need to eat their lunch. So if we could come down to the corner here and we can chat until these guys, look totally hungry. And we'll start the next session at 2 p.m. Thanks very much.